Hi everybody, I am hoping that I am live and you all can see me. So as I always say, Andariki Namaskaram, Ellargu Swagatam and a very warm welcome, that is Vanakkam to Vedantu J English channel. This is me, your master teacher Nabamita Ma'am, and today we are going to complete this chapter that is called as Electrochemistry. The session is going to be around 2.5 hours to 3 hours. We also have a lot of questions. Some of them are PYQs, some of them are questions that I've picked it up from various books. So yes, everybody, are we all ready? Now I quickly request you all to go and call up your friends because this session is going to be extremely essential. We are going to cover everything, basically starting from what is a Daniell cell, what is a cell, what is an electrochemical cell, electrolytic cell, to the fact that we will be completing preferential discharge theory, we will be completing corrosion, we will be completing Kohlrausch's law. Everything will be completed in this session, everybody. Now for this session, who all should actually who all should actually come and watch this session? Those students who have never heard of this chapter, that is electrochemistry. Those students who are preparing for JEE second attempt, those students who are preparing for the next year 2025, it is applicable for them as well. So everybody is welcome to watch this session. It will be from basic to absolutely everything. All right guys, yes, and I will be giving you PDF as always. I'll be giving you the PDF. Now in this session today, what I have done is, just so that I do not waste time, I have also written a lot of things, that is handwritten, like these things. Okay, these are all handwritten by me. You can look at it, you can understand that this is my own handwriting. So yes, these things are written by me and it will be there. Okay, all right everybody, so let us start. But before I start, my dear student, there is one thing that I need you all to understand is, if you are someone who is scared that I do not know, ma'am, how to score this, I do not know what to do, yes, then let me tell you that Vedantu Learning Center is right in your city. Vedantu is there in NCR, Punjab, Muzaffarpur, Rajasthan, Karnataka is there, in Tamil Nadu. In fact, Tamil Nadu, we have 4 to 5 learning centers, everybody. So all the students who are Tamil, your exam, all the Tamilian students, everybody, my Pasangalas, you guys have a chance to make your JEE Jujupi stuff, everybody. So quickly go head out to the Vedantu learning centers. You have a lot of learning centers in Tamil Nadu, everybody, and you know that you are going to get dedicated academic mentor. You will be getting a small clicker in the class so that you can, interact with the teacher, and we have 3-way doubt solving, everyone. Yes, you will have qualified teachers, you will have great content, as you all can see and as you all know. And there will be rigorous test and practice, because guess what? We have 3 types of different tests. We have learning progress test, we have regular test, and we have mock test. So I think it's a great. And test is essentially the essence of your competitive exam. So if you are not sitting for test, if you're not solving problem, then how will you solve problem in your exam, guys? Yes. And one of the best thing that we have in Vedantu is Vedantu Improvement Promise, everybody, because we are so confident about our teachers. We are so confident of our content. We are so confident that the Vedantu's vibe is going to be rocking amazing, that we also come up with this promise that if you do not get an improvement in your marks, then we will give your money back, which nobody else, none of the other edtech, none of the other institutions will ever come and tell you. So guys, go ahead, trust Vedantu, because you know that we are giving you a guaranteed improvement promise, everyone, right? Yes. Now in different centers, there are different courses. So what I need you to do is, if you just head out to our just go to Vedantu J English channel right below this video, everybody. If you come and check it out. So this is my session, right? What am I going to do is, I'm going to look for Vedantu JEE English. Okay, everybody. Just before this, right here, I'm searching for Vedantu J English channel. Here, this is our channel. This is me taking a live session, and I can see that many students are liking. Many students are watching this session, but you guys are not liking. So I have liked the session. You too like it. So all you have to do is just click on this more. Okay, I've clicked on this more, and here you will see book a visit to the nearest learning center. So just go ahead, click on this link, click on this link and fill it up, everybody. Our team will help you with everything. They will tell you about what are the courses, they will tell you about the enrollments, they will tell you about everything, and this is how you enroll. Okay, all right, so go ahead and do that, everyone. Go ahead and do that. I think that you guys will be finding it a lot beneficial for you all. So here we are going to start with our session right now. No more delay, everyone. Arey, what just happened? Okay, 5:40, that's right now, right? Isn't it? 1 second, guys. 1 second, everybody. Anurag, you're from Lucknow. I think we have a Vedantu Learning Center even there. So just give me 1 moment. I'm just trying to open this notes. Otherwise, yeah, there we are. So guys, we're starting with electrochemistry. Everybody is ready. Now, first of all, the first thing that we want to know about electrochemistry is, what is electrochemistry, Baba? What is electrochemistry, right? This is what we want to know. So as it is written right here on the board, you can see that electrochemistry, my bachus, is basically that study. What is it? It is that study of electricity and how it is, how it is related to chemical reaction. Okay, how it is related to chemical reaction. That is your electrochemistry. So basically, overall, if I really want to talk about electrochemistry, I am telling you that in chemistry also we have electricity, and in electricity we have certain bit of chemistry. How so? How is that possible? Of course, when you have a cell means battery. Battery, you all know. Battery, I'm sure that you all know, isn't it? Yes. So when you have a cell, inside the cell there is some amount of chemical, right? When the chemicals are reacting, they will be producing you some energy. That energy will be called as chemical energy, and from that chemical energy, when you touch with copper wires on the two sides of the battery, we get a ting, a bulb glows, right? What is that? Electrical energy, everybody. So that means that when chemical energy is converted to electrical energy, it is a part of electrochemistry. And when electrical energy is converted to chemical energy, that, my dear student, is also a part of electrochemistry. However, here, can you guys see that there are two terms that I have written? One is spontaneous, one is non-spontaneous. What is spontaneous, everybody? Spontaneous bole to, today, if I, let's say that, okay, let's say that I just want to talk to, Sanjay is asking me, ma'am, will you give me a PDF, right? Now, giving you PDF is actually a spontaneous reaction, because after I'm done taking the session, I know for a fact that my students will be waiting for the PDF. How else will they study? And it's not possible that you watch the lecture, you concentrate on the lecture, you also take notes, you also solve problems. Too much. So that's a spontaneous reaction. It is my duty to provide you with the PDF as soon as the class is over. That does not require any energy. The moment class is over, I have to give you the PDF, right? Yes. But like yesterday I took a session, do you remember? Yesterday I took a session wherein I told you about the analysis of the JEE first attempt, isn't it? Yes, the JEE January first attempt, right? I have taken a session yesterday, and at that point of time I told you that I will not be able to give you this PDF because this is Vedantu's IP. So it took me, like for that, if you now force me that, ma'am, please send, I don't want to give it to you. That's a non-spontaneous reaction. And what did I do? I asked you all to take a screenshot. So that's like a non-spontaneous reaction. Basically, this was just a funny example that I gave you. But spontaneous reaction is those kind of reactions which are capable to proceed in a given direction without any external energy. You do not need to help somebody, or you do not need to help them at all, but the reaction just happens. For example, when you keep chemicals together, obviously, Baba, chemicals will react. That is their essence. That is their whole behavior, right? Chemicals will react. Exactly. But also, do you remember there is a chapter called as chemical kinetics, where we study about if this reaction is feasible, if this reaction is not feasible. So there are certain reactions which are not feasible, and you have to provide some external energy that, or a reaction ho ja, let the reaction happen. You have to happen the reaction, right? So that is your non-spontaneous reaction, where you have to give in some external energy. Getting my point, everybody? Yes, guys. Chalo. Moving on from here now. Now, when we are talking about, spontaneous reaction, electrochemistry, when we come across electricity, we understand that there are certain terms. I do not know if you guys can see this. Is it too small a letter? Don't worry, even if it is too small, guys, let me tell you that here what I have written is conductors. What are conductors? Conductors are basically those substances that conduct electric current, which we all know, right, everybody? Yes, we all know that conductors are those substances that can conduct electricity. Conductors, when we speak about, before conductors, we also know that substances can be divided into three, that is conductors, insulators, semiconductors. Now, conductors have a large conductivity. That means they can conduct a lot. Insulators, they do not conduct at all. They have very small conductivity. And semiconductors, their conductivity lies between conductors and insulators. Right, so this is what I have written here, and of course I'm gonna give you the PDF, don't worry about it, okay? But here if you look at it, guys, when we talk about conductors, now all these while before our 10th standard, my dear student, you know what we were talking about? We were talking about metallic conduction, isn't it? What were we talking about? We were talking about metallic conduction. But now in today's session, we will also be talking about, you know what? There's something that is called as electrolytic conduction, okay? There is something that is called as electrolytic conduction. Getting it? One second, let me. Actually, you know what? Let me just keep this here. Okay, now can you guys see this? Now is it possible? Yes? Chalo, I will zoom it, yeah. Now can you guys see? Right here, yes. So what is metallic conduction? Metallic conduction is basically the movement of electrons that causes the electric current. In metallic conduction, we know that electrons move, right? Electrons move, isn't it? But in case of electrolytic conduction, that's not the case. In electrolytic conduction, but choose what happened is the movement of ions, they cause the electric current. Are you understanding, everybody? Yes. Now, here if you come here, you will see that there is no chemical reaction. In a metallic conduction, basically when you are connecting a copper wire in your house, do you see that there is a chemical reaction that is happening? None. None whatsoever. It is just electrons that are moving from one place to another, electrons that are moving from one place to another, and they are also carrying current. Isn't it, everybody? Very good. Yes. But here, ions, what they do is they get ionized. That means they are reduced at the electrodes, right? They are reduced at the electrode. That means there is a chemical reaction that is happening in the electrolytic conduction. Isn't it, everybody? Moving on, then what happens is, if you increase the temperature, in case of metallic conduction, my dear students, the resistance also increases. Of course, the more heat you give, what happens? All the electrons, they start moving with higher speed, they collide, and the resistance also increases. However, in fact, here, in case of electrolytic conduction, you do not see that happening. You see that the resistance decreases when you increase the temperature. Yes, that is what happens. All right. So basically, these are the differences that we talk about here. Yes, and as and when we move forward, you will notice that you are understanding this metallic and electrolytic conduction a little better. Now, guys, I'm just reducing this space so that when I send you the notes, you will be able to read it. But right here, if I keep it like this, it looks very funny. It looks like it is half cut. Okay? All right, don't worry about it. I'll be sending it to you. Okay? All right. Now here, once again, I have written it just so that you can read it a little better. Okay? Here, once again, I have written the differences between metallic and electrolytic conductance, and you will be able to read it in the PDF, because I'll be giving you the PDF. Don't worry about it. Okay? Alright, now my dear student, let us start with this chapter. In this chapter, we are talking about electrochemical cell. Now, what is electrochemical cell? But choose the moment we hear electrochemical cell, we understand that there is a relation between electricity and chemistry. Or there is a relation between chemistry and electricity. Yes. So when we are talking about electrochemical cell, we come across two things, okay? We come across two different types of cells. Number one is your electrolytic cell. Alright, the number one is electrolytic cell and the other one is a galvanic cell. What does the galvanic cell do? The galvanic cell, what it does is it converts it converts chemical energy into electrical energy. Basically, the usual batteries that you have, yes, the ever ready Duracell batteries that you have, isn't it? Those are the sort of galvanic cell, because what do? They have chemicals inside them. The chemical energy gets converted to electrical energy when you put them in a remote, when you put them in your microphone, right? Even this microphone that I'm using, this also has a battery. So yes, these are your sort of galvanic cell. We will be studying about batteries at the end of the session, so don't worry about it, okay? All right, and here, my dear students, we have electrolytic cell, right? Now, electrolytic cell, everybody, if you have if you just notice here, you see that non-spontaneous. That means the reaction is not happening on its own. You have to provide some electrical energy. You have to provide some external energy so that it gets converted into chemical energy. All right, so that it gets converted into chemical energy. Are you getting it, everybody? Till here, no doubts, I'm hoping. Till here, you should not be having any doubt, right? Yes, till here, I don't think that you should be having any doubt, isn't it? Okay, guys, 1 second, yeah. Okay, all right, okay, yes, take it. So moving on, everybody, moving on from here. Now let us have a look at this galvanic cell, everybody. Yes, this galvanic cell. Can you see, everyone, that what have they done? Right, okay, this side, sorry. This side, if you look at it carefully, you will find that there is a zinc rod and there is a copper rod on the other side, right? If you're not able to see, don't worry about it. Chalo, let's talk about this here. So in this side here, you have a zinc rod. What do you have, my dear students? What do you have? You have a zinc rod here. Okay, you have a zinc rod here, and on the other side, this side, that means here you have a copper rod. Okay, here you have a copper rod. All right, everybody. Okay. Now, the zinc rod, it is dipped in ZnSO4, that is zinc sulfate solution. And the copper rod is dipped in copper sulfate solution. Alright. Now, zinc has a tendency to do what? Zinc actually loses 2 electrons and it gets converted to Zn2 plus, my dear student. Okay. Zinc gets converted to Zn2 plus, everyone. Okay. So that means that when it is becoming Zn2 plus, the Zn2 plus comes in the solution, right? The Zn2 plus is in the solution, and right here you will see electrons are getting accumulated, as in jama ho rahe hain. Electrons are getting collected here in the rod. After it is getting collected, do you think that electrons will forever stay there and chill that yeah, we are going to be here only? No. Electrons, they have a tendency to move, isn't it? So what do these electrons do? They, my dear student, they start moving, and they come here. They start moving, and they come to the copper rod side. They come here, okay? Now copper, understand this, everybody. So you had copper sulfate, right? So what will copper do? Copper and sulfate, they will dissociate. So copper will become Cu2 plus, SO4 2 minus. This copper 2 plus that you see, this copper 2 plus, right? This copper 2 plus will be like electrons. It has certain affinity towards electron, isn't it? Yes. So this copper 2 plus, it looks at the electron, grabs hold of it and gets converted into copper, and now this copper starts depositing on the rod. So after a while, you see that the copper rod becomes thicker and thicker and thicker, whereas the zinc rod becomes very tiny, because the zinc is giving away electrons, the copper is grabbing hold of the electrons, right? So copper is getting deposited, everybody. Yes. Now you must have noticed, everyone, that the electrons, they are flowing from the zinc rod to the copper rod. So what do you call this zinc rod? I'm saying that zinc rod, zinc rod, copper. It does not sound very science-like, isn't it? Yes. What is the zinc rod and copper rod? I mean, we are not in a construction class, obviously. We are definitely in a chemistry class. So guys, what do we say? Now we are going to talk about electrodes, and electrodes are two types. You have anode and you have cathode. So wherever oxidation is happening, that part is called as, or that electrode is called as anode, and wherever reduction is happening, that is called as your anode. Yes, everybody. So that means that the zinc rod where oxidation is happening, what am I going to call it? Yes, what am I going to call it, guys? If oxidation is happening, that means this is our anode. And wherever reduction is happening, which is the copper part, that will be our cathode. Isn't it, my dear student? Yes. So how do you remember it? You can always remember this mnemonic, that is red cat and ox. Okay, what is it? Red cat and ox. That means reduction is always at cathode, and at anode you always have oxidation. Okay, and there is another mnemonic which I think we all learn it in your what you say, you all learn it in the redox chapter. However, I'm just going to tell you here how to remember that which side is oxidation and which side is reduction, everybody. Oil rig. Remember this mnemonic, that is oil rig. That means oxidation is the loss of electron and reduction is gain of electron. So everybody, do you see here that copper is gaining 2 electrons? See, plus 2 electron. Copper is gaining 2 electron. That means this is reduction. And here, do you notice that zinc is losing electron? Zinc is losing 2 electrons. So that means this is oxidation. So guys, everybody, I'm hoping that till here, nothing, you guys have no doubt whatsoever. Till here, is there any doubt, everybody? Yes. Is there any doubt, guys? I hope that nobody has any doubt till here. Yes. Yes. Right, everybody? Okay. Till here, no doubt. Correct? Okay, guys. Moving on from here now. So this is basically what I told you. This is just typed out version. Okay. This is just typed out version. But I have already explained you all of these. Okay, guys. Now here you see that there is a cell name that is written. The cell name is a Daniell cell. You must be thinking, ma'am, what is Daniell cell? Nothing but a Daniell cell is basically a type of galvanic cell. Okay? Daniell cell was prepared by somebody named Daniell. Obviously, his name was John Daniell, John Frederick Daniell. He was the one who designed the first Daniell. Obviously, that is why the name Daniell cell. Right? It is a electrochemical cell, but in electrochemical cell also there is the galvanic cell that we are talking about, right? So that is a type of this Daniell cell. Okay? Alright, yes. We also call this galvanic cell sometimes as voltaic cell. Okay? We also call it to be as voltaic cell, which has copper and zinc electrons. So basically right now what I taught you, where there is a zinc rod, there is a copper rod, that, my dear student, is nothing but your Daniell cell. Okay? Wherein you have copper sulfate and you have zinc sulfate, which is separated in 2 containers. These 2 containers that I have just told you, right? These two containers, because they are like, so together, if you just complete the whole setup, yes, the zinc rod with zinc sulfate, the copper rod with copper sulfate, together, if you complete it, you might want to call it a cell, right? Yes, that is what we are talking about, that this is your Daniell cell, everybody, isn't it? This is your Daniell cell. So, my dear bachos, can I not call the zinc rod with zinc sulfate as a half cell? And the copper rod with copper sulfate solution, can I not call that also as a half cell? Right, everybody? Yes, ma'am can definitely call it to be 2 half cells. Yes. Now, because in the zinc side, what was happening? Oxidation was happening. So, let's call that to be as oxidation half cell. And because in the copper side, reduction was happening, let's call that to be as a reduction half cell. Can we not do that? We can do that. Yes. So like every galvanic cell, this Daniell cell, what it does is this also converts some chemical energy to electrical energy. So basically chemicals are there. These chemicals, they are going to react, they are going to provide, they are going to liberate, they are going to produce some electrical energy, and from that they are going to produce some chemical energy. And we all know that energy cannot be destroyed, but energy can be transferred from one place to another. So basically that is what is happening, right? We have just converted it from chemical energy to electrical energy, and that's it. And this is the whole reaction that is happening, everybody. As I have written, I've just showed you, isn't it? Did I not show you that zinc was losing 2 electrons? So see, zinc Zn lost 2 electrons and it became Zn2 plus here. And copper, it gained 2 electrons and from copper 2 plus it became Cu. It became copper solid. That's it basically. Okay. All right, yes, but the question is that, but how does the electricity exactly flow? So guys, all these time, do you remember I just showed you here that what will happen here is, one second. What is happening? Why is it moving forward? I wanted to move backward. Yeah. So here, my dear students, if we are, if we take a look at it, tell me something. After some time, what will happen? Electrons will be here, isn't it? After some time, electrons will be here, electrons will be here, electrons will be here. So, but tell me, bacha, that electrons are negative, right? Electrons are negative. Now that electrons are negative, and here in the solution, now you know that zinc is doing what? Zinc is losing electron and it is forming Zn2 plus, isn't it? So here you have Zn2 plus. So after some time, the electrons which are negatively charged and Zn which is positively charged, they will be collected, isn't it? And this electron, the electron will be like, I am negatively charged. To find the positive charge, why do I have to run dun 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 and go to the copper rod? Instead, I have Zn2 plus. I will attack the Zn2 plus. Electron will obviously have an affinity, isn't it? Electron will obviously have an affinity, isn't it? Of course, everybody. So after a while, what happens? The current flow stops. Yes, this current flow that was happening, this electron flow that was happening, after a while the current flow stops. And that's when we are asking the question, Anya, how do we do this now? Now how do we make the electricity flow again and again? How do we make sure that the electricity is flowing continuously? At this point, everyone, we introduce something that is called as salt bridge. Okay, and this salt bridge is what you see here written as the KCl. KCl is potassium. Cl is what? You all know, right? I'll write the answer in the chat box anyway. And please, come on. Don't tell me that, ma'am, we don't know what Cl is. One virtual slap will be coming towards you, okay? If you do not know what is Cl. Write it down, guys, quickly. So this KCl that you see, that is your salt bridge. So let us talk about this salt bridge, everybody, okay? Just moving ahead a little bit. Yes. So I have written here that Zn2 plus, after some time, it gets collected in the solution, right? And similarly, in the copper side, because there was copper sulfate, copper was grabbing hold of 2 electrons and it was forming solid. Copper was grabbing hold of 2 electrons and it was forming solid. But SO4 minus was lonely. I am so lonely in the solution, right? Yes, SO4 minus was left behind in the solution. So both of them are getting collected. The electron will think, bro, if I go to the copper side, I will be attacked by the negative ions. Why should I go there? I will rather attack the Zn2 plus, right? This is why we are introducing salt bridge. Now, what is salt bridge? Is the name looking very sophisticated? It is not, my dear students. Salt bridge is basically a glass tube which is U-shaped. It's a glass tube which is U-shaped, okay? And it is filled with salt and there is a polysaccharide gel, okay? Mostly you can use agar. It's a gel. Gel, you understand, right, guys? Gel, everybody knows, isn't it? Yes, exactly. So that gel, right? But now you might be asking question that, ma'am, why gel? Arey Baba, gel. What does a gel do? The gel basically makes it very, how do I say? Sort of slippery, right? It's like a lubricate, isn't it? It's sort of like a lubricate. So what happens is the electrolyte, guys. Now what is electrolyte, you are going to ask me? The salt that you have, that is only electrolyte, isn't it? Yes. K and Cl, K plus and Cl minus, what are those? Electrolyte? Yes, absolutely, everybody. We are using the cells so that the electrolyte can go into the solution easily. And what kind of salts will we use? We will be using KCl, we will be using KNO3, sometimes we use NH4NO3 and etc. Okay? But you have to remember that when we are not using KCl, if in the electrodes you see there is Agra, Thailand, Punjab and Hong Kong, that means silver, thallium, lead and mercury. If these are the 4 electrode, at that point of time, you are not going to use KCl, you will be using some other salt. Acts like a butter. Very good. Yes, smooth like a butter. Smooth like a butter, less friction. Very good. Thank you so much. Yes. Thank you so much. Yes. Yes. Tanishka, I think, see, Aaron and King Aiki, they have just answered your question. Why are we using the gel? Because it makes it easier for the electrolyte to pass on to the solution. Less friction. Yes, it's very smooth. So they go into it. Now the question that you might still ask is, why are we using the salt bridge? We are using the salt bridge because you saw that there was junction potential. In one of the sides, Zn2 plus Zn2 plus Zn2 plus was getting collected. In the other side, SO42 minus SO42 minus SO42 minus was getting collected. So what was happening? This was junction potential, and right at the junction there was a potential that was arising. The electrons were not able to flow to the other half of the cell. There was junction potential. So that junction potential we are trying to reduce here. When you put the salt bridge, it completes the circuit. Yes. Now not only the electrons are flowing this side, but now they are completing the circuit. Yes. And we know, even in your very choto moto classes, you all know that a circuit cannot be open. Circuit has to be complete. Circuit has to be closed. And here, after using the salt bridge, the circuit is getting completed, my dear student. Yes. And it also tries to maintain electrical neutrality of the half cell. Otherwise, Zn side, the zinc side, becomes positively charged. The copper side becomes negatively charged. So that they do not have charges, so that the neutrality is maintained. Here we use salt bridge. So abhi tak, till here, I'm hoping you guys do not have any other doubts. Do you have any other doubts, guys? I hope that everything is clear related to Danielson. I hope that everything is clear related to salt bridge. Is it all done, everybody? Anybody here, any doubt? Yes. Anybody, any doubt? Yes. Baba Tanishka, KCl, it's a salt, it's a solid, right? So if you just put it in the tube, that is the salt bridge, how will it go to the solution? It will not, right? So when you use a gel, the substance can get inside the solution easily. Okay. Understanding? If you just have the powder, then it's basically like you are adding potassium chloride into the ZnSO4 solution. Then they will start reacting. So you want a bridge which connects both the half cell, and there is an ease of the salt getting into the solution. Are you getting my point now? Now I hope that it is clear. Yeah. Now I hope that it is clear, everybody. Yes. Cool. All right. Yes. Yes, very good. Thank you so much. Game over. Yes. No, ma'am, to what? No doubt, or no, ma'am, to you did not understand? Ira, please use your common sense a little bit, bacha. Please use your common sense. What happens? Yes. What happens when you heat a solution? When you heat a solution, there is a gap that comes in. And when you are heating the solution, you are also providing them with more energy. Plus, you know what is happening? The state change is happening, right? From liquid, they're trying to get converted to gaseous. So there is more space. There is more amount of movement. That means that resistivity is decreasing and they want to run faster. That does not happen in the metallic metallic conductors, because metals, they will try to, even if you increase the heat, at the least what can happen is from solid they can only get converted to liquid. But here what is happening is, more than the melting, the electrons are trying to collide with each other because solids are packed very tightly. That is why. Okay? All right. Yes. Any prerequisites of equilibrium for this? Just a little bit, but don't worry, I will be teaching that to you any which ways. Okay, I'll be teaching that to you. Okay. All right. Okay. Shall we move on then? Shall we move on, everybody? Yes. Any other doubt, guys? Any other doubt? Why not conductor? You can use a conductor, but what if the conductor only starts reacting in the solution? Science hai baba. Use your scientific mind a little bit. Hai na? Chalo guys. Moving on. Okay. So now when we are now we are going to get introduced to certain more terms, everybody. So pay attention. Okay. Pay attention. No standardities. Okay. So we know that the flow of the current is possible. When is it possible, guys? In your, yes, What does neutrality? Hey, Ashik, you are not listening to me or what? I've just explained it to you, bacha. What is electrical neutrality? Haven't I told you, everyone? People, I feel like you are not listening to me, huh? I really feel like you are not listening to me. Why are you not listening to me? That I do not know. Okay. Bachu, electrical neutrality. Do you remember? Without the potassium chloride, without the KCl, in one side Zn2 plus was increasing, right? And in the other side, copper was getting converted to solid state and SO4 2 minus was increasing. That means in one half of the cell, positive charge was increasing. In the other half of the cell, negative charge was increasing. We do not want that. If that happens, that electron will not be able to travel from one half of the cell to the other half of the cell. That is why we use the salt bridge, so that the Zn2 plus charge and the SO4 2 minus charge is not there. The Zn2 plus reacts with the Cl minus of salt bridge and SO4 2 minus combines with the K plus of the salt bridge. That's how they maintain the electrical neutrality. Samjhe bachcho? Ashik, now do you understand? Please tell me yes, okay? So basically, when this was happening, right? When this was happening, when do you think electrons? In your physics chapter, I'm sure that you have studied, right? Because of potential difference. Acha bacho, let's, forget about physics, guys. Let us understand with a story, everyone. Okay. My very famous example. So everybody, you must have seen that Jamnagar Ambani sir's son got married, isn't it? Anant Ambani recently got married, right? Yes. Okay. Anant Ambani recently got married. Acha, tell me. So when Anant Ambani got married, worldwide, Mark Zuckerberg and Rihanna and Bill Gates and everybody, we are all interested. Like, oh, what is happening? What is happening? Why? Because so much money. Yes. Do you think when my wedding happened, do you think that Bill Gates and Anant Ambani and Shah Rukh Khan and Rihanna, everybody was interested? Do you think that? No, obviously not, right? Obviously not, everybody. So now, why is that so? Because money, entertainment is flowing or money is flowing. We all want to look at them because my goodness, they have so much money. Why do people don't watch? Why didn't people watch my wedding like this? Why wasn't Rihanna or Mark Zuckerberg not invited in my wedding? Because I don't have that much money. So where does money flow from? Money flows from where there is a lot of money to the people we don't have money. Again, similar example, everybody. Do you think that I will be giving Anant Ambani sir a job? Do you think that I'll call Anand, bro, I have a job for you, Per class, I'll give you 50 rupees. What will happen? Anant's bodyguard will pick me up, put me in jail, right? But Anant Ambani can come and tell me that, you know what, we are starting a new educational company, and Nabamita Ma'am, we want you to join. He can give me money, right? Right? Why is money flowing? Money is flowing from higher potential to lower potential. People who have more money to people who have less money, right? I obviously do not have money like Ambani. Cannot happen, isn't it? Right, everybody? Exactly my point, guys. So why is the electron flowing? Because there is some place where the potential is higher, some place where the potential is lower. That means there is a potential difference which is making the electrons flow. Right? And this potential that is associated, that means that is related to this, electrode is called as electrode potential. That means when the zinc is an electrode, right? The zinc rod that we have taken, what is that? Oxidation is happening. So anode, the zinc rod was anode. So the zinc rod and the zinc sulfate, they had a potential difference. The copper rod and the copper sulfate solution, there was a potential difference. So this is called as the zinc rod, that will be electrode potential. The copper rod, that will be another electrode potential. So guys, are we understanding what is electrode potential, everybody? Yes, we do. Yes, we do. I'm hoping that you do not have a doubt here. Yes. So the potential difference between the electrodes, okay, between zinc and the copper in a Daniell cell is actually 1.1 volt. Now you will ask me, ma'am, how did we calculate this? But choose, here is the salt bridge, right? Actually, right here we also use a voltmeter, and this voltmeter we will come to it, yes, when we are studying standard hydrogen electrode, right? Standard hydrogen electrode, when we will study, that time we will understand how we can figure out the reading in the voltmeter and how we can relate it. So guys, everybody, I hope that there is no doubt here. Yes, there is no doubt here. But here is a question for you. Can somebody answer me this, that what will happen if you apply any external potential in the Daniell cell, guys? What do you think will happen? What do you think will happen, everybody? Yes. If we apply some, what are we trying to apply here? If we apply some external potential, then what will happen? Darshika, that's a very easy answer. Yes, I agree to you, but I also do not agree to you. Just for a little bit, okay? There are three different cases, okay? When we apply external pressure, there are three different cases that we see, everyone. Case number one, when the E external, that is the external current that we are applying, okay? 1 second, guys. I do not know what is this happening, okay? So the question here was, yes. So if the external potential is lesser than the 1.1 volt, that means the electrode potential. If the external potential is lesser than the electrode potential, then everything will remain as it is. Everything will remain as it is. Yes, the electrons will flow from zinc to copper, and the current will flow opposite from copper to zinc. Alright, yes everybody, great. But case number two, if the external potential is equal to the electrode potential, that is 1.1 volt, then what will happen? Nothing will happen. At that point of time, there will be no flow of electric current. For example, everybody, now Mark Zuckerberg and Bill Gates, both of them are equal almost, right? Who's going to give money whom? Nobody. They are all friends, right? They are all friends because nobody gives money to anybody. Both of them are friends, isn't it? Yes. But Mark Zuckerberg and I cannot be friends. He has to give me a job. Correct, everybody? Understanding? So here also you will find that there is no flow of electric current or no flow of electrons, everybody. Okay. But if the external potential is higher than the electrode potential, that is 1.1 volt. At this point of time, my dear students, you know what happens? The Daniell cell, that is the galvanic cell, starts acting like the other type of electrochemical cell, isn't it? So here now, electrons flow from copper to the zinc and electricity flows from zinc to copper. Are we clear with this, everybody? Yes, this is the time when the reverse happens. Okay, this is the time when reverse happens. Okay, all right. Now we come across that all of these cell that we spoke about. Everybody, bacha, do you think that we are going to write that zinc is dipped in zinc sulfate, copper is dipped in copper sulfate, we have a salt bridge in between, you know, we have this much wood. Are we going to write all of these? Are you going to write all of these in your exam? Not at all. So how do you represent a cell, everybody? Right in the between, everybody, you will write here salt bridge. For the salt bridge, you will put two dandas, okay? You will put two sticks. Two sticks means salt bridge. Okay? All right. On the right hand side, this is the right hand side only, no? Right now my right hand side, if I face it like this, then my left side. So yeah, on the left side, you will be writing anode reaction. On the right side, you will be writing the cathode reaction. So in the anode, what was happening? Zinc was losing 2 electron and it was forming Zn2+. That's exactly what we have written here. Yes, that's exactly what we have written here. On the other side, copper was grabbing two electrons and it was forming copper solid. So that is what we are writing on the left hand side, everybody. And that's it. Simple, simple, easy peasy, biryani tasty. Two dandas, two sticks means salt bridge. One stick, this is for phase difference, okay? This is to differentiate the phase. Here see, metal is the solid, solution is in aqueous form. So phase is different, isn't it? One vertical line means you are differentiating the phase. Two vertical line is the salt bridge. Okay. Alright everybody, am I clear? Am I clear guys? Do we have any other doubt till here? Representation of cell, everything is clear guys. We have no doubt. Do we have any doubt? Do you have any doubt everybody? Do you guys have any doubt? Yes or no? Thank you, Bharat. Thank you so much. Thank you, Govardhan. I am from West Bengal. Okay, I am from West Bengal, everybody. Yes, guys. Are we done? Is there any doubt? If there is no doubt, shall we solve a question? And here is a question for you. The question is, a similar cell to Daniell cell is constructed with the following reaction. At electrode, you have A forms A2 plus 2 electron. Here, see what is happening. Basically what is happening here? Loss of electron is happening, isn't it? Loss of electron is happening, see? Yes, from A, it is forming A2 plus. Loss of electron, guys. Oh my god damn. What is happening here? Loss of electron, everybody. Loss of electron, bole to oxidation. Right? Bole to oxidation. Am I right? Oxidation is loss of electron. Very good. Okay. Alright, yes, at electron B, B2 plus now is grabbing 2 electron. That means gain of electron is happening. If it is gain of electron, guys, that means here what is happening? Reduction is happening, everybody. Okay? So if oxidation is happening, oxidation happens where? Oxidation happens at anode, isn't it? Where does reduction happen? Reduction happen at cathode, everybody. Now read the statements. What is the statement? Statement 1 says electrode Y is where reduction is occurring, hence it behaves like an anode. Ayo, how is that right? Electrode A is where reduction is occurring, that part is true. But does it behave like an anode? No, it will behave like a cathode, everybody, isn't it? Yes. Electrode X is where oxidation is occurring, absolutely right. Hence it behaves as a cathode. No, it behaves like an anode. But option C, see, look at option C. The flow of electron is from electrode X to electrode Y. Absolutely. Wherever oxidation is happening, from there the electrons will go to the reduction side. So yes, my dear bachos, option C is absolutely correct. Yes, option C is absolutely correct. Easy peasy biryani tasty. Was there any doubt here? Was there any doubt here? Everybody understood this. I hope everybody understood this, isn't it? Yes. Thank you, Janvi. Thank you so much, guys. Very good. Very good. See, we were right. Okay, next question, guys. Which of the following cannot be used as a semi-solid paste inside a salt bridge? What are the examples that I gave you? I gave you example of KCl. I gave you example of KNO3. I gave you the example of NH4NO3. Now, you also know that sodium chloride is also a salt. So, salt bridge, the name itself is salt bridge, everybody. That means NaCl, KCl, NH4NO3 will be used. But CH3Cl, what is this? What is CH3Cl, guys? You guys know about organic chemistry. You tell me, what is CH3Cl? What is CH3Cl? It's a halide, right? It's what? Methyl halide, methyl chloride. So that obviously we will not be using in salt bridge, right everybody? Moving on to the next question, guys. The next question is, for the following half cell reaction, the correct cell representation would be oxidation half cell. Fe forms Fe2 plus 2E minus. Reduction half cell is Cu2 plus 2E minus. Okay guys, how do we do this? We will be writing it as everybody see. Reduction half cell and oxidation half cell is given. First of all, let us write the salt bridge, right? If this is the salt bridge, done. Then what do we do? Anode. We start with anode on the left hand side, isn't it? So oxidation happens at anode, right? That means that we will have FeS which goes to Fe2 plus in aqueous. Am I right everybody? This is what we will write in this side. On the other side, what do we have? We have copper. So that means that Cu2 plus in aqueous form goes to copper solid. This should be the ideal notation, isn't it? And where do you get this? Is it option B, my dear students? Is it option B? I feel like it is option B, isn't it? Is it option B, everybody? Yeah, option B. Very good. Thank you so much. Yes, it is option B. We are absolutely right. Clap for yourself, guys. Quickly clap for yourself. Yes. This was also EPBT. Easy peasy, biryani, tasty. Alright, everybody? Yes. Chalo. Shall we move on then? Shall we move on, everyone? Let us move on. Chalo. Okay. Now guys, when we were talking about, very recently we were talking about electrode potential, isn't it? Yes. तो अब electrode potential होता क्या है भाई? What really is electrode potential, guys? We have just spoken about it. When will you take session for VIT? Bharat, we haven't decided on it yet, but we will talk definitely. Shrey sir, me, Nabamita Ma'am, Durgesh Ma'am, we will definitely have a meeting and we will decide and we will let you know, okay? Alright, bacha? Till now we haven't decided though, okay? So you have to give me a little time. I'll decide and we will decide and we will let you know, okay? Very good. Clap for yourself. How much do you win? You guys win 1,000 rupees, okay? Virtual. It is not kaun banega crorepati, okay? So today we will see how much money you win, okay? So you have all won 1,000 rupees. Next question, you will win 2,000 rupees, everybody. So chalo. Potential, electrode potential, everybody understood what is electrode potential? The potential difference that is developed between the metal electrode, that is the metal rod, and the ions in the solution. So electrode potential is done. But bacha, chemistry hai. This is chemistry. This is science. We also have to standardize things, isn't it? Because if we do not standardize, then what will happen? Then in India, we will be talking about something else. In USA, they will be talking about something else. So that's not possible. We will be standardizing it. So now we come across something that is called a standard electrode potential. And what does standard electrode potential means? Nothing different. Nothing different. All you write is potential difference. Very good. Developed between whom? The rod, yes. The metal rod, yes. And developed between whom? They developed between the solution of its ions, absolutely. But there is a condition now. That condition is at 1 molar concentration, 1 bar pressure and a particular temperature. What is the particular temperature? The particular temperature will be obviously 298 Kelvin, right? Great. Now, there are also two different types of electrode potential. Obviously, Baba, at the zinc rod side, what was happening? Oxidation was happening. At the copper rod side, there was reduction happening. So, can you call both of them electrode potential? Even if we are calling electrode potential, we are understanding that one of them is going to be oxidation potential, one of them is going to be reduction potential. Obviously, self-explanatory. Do I need to explain this? I guess you are understanding, right? One side, oxidation was happening, another side reduction was happening. So one side will be called as oxidation potential. The other one will be called as the reduction potential. So the electrode potential for the oxidation half reaction. Where was oxidation happening, guys? Zinc side oxidation was happening. Zinc was losing electron. So that the zinc rod and the Zn2 plus ions in the solution, that is your oxidation potential. Why? Because they have a tendency to get oxidized. Achha, do you think that if I give, a lot of electrons in front of zinc and I tell zinc that hey, Zn2 plus, why don't you get converted to zinc? Yeah, zinc will not. You know why? It does not have a tendency to reduce itself. It has a tendency to get oxidized, and that you will be learning about it when we go through our electrochemical series, everybody. You're getting my point, isn't it? Yes. So greater the oxidation potential, greater is the tendency to get oxidized. Alright? Yes. Similarly, you can write it for reduction potential, the electrode potential for the reduction half of the reaction, that means the copper side. This has a tendency to get reduced. It does not have a tendency to get oxidized, and greater is the reduction potential, greater will be the tendency to get reduced. Now guys, IUPAC, the big godfather, the big daddy of chemistry, that is IUPAC, have told us that we will always consider reduction potential, okay? So as per the big daddy of chemistry, we will always mostly talk about reduction potential. That you must remember when you're writing your exam. ठीक है? You do not consider you do not consider oxidation potential, you consider reduction potential. Am I clear, everybody? Yes, guys. Now we come across something that is called as electrochemical series. What is electrochemical series? Nothing, bacha. In our younger classes, we have read about reactivity series, isn't it? We know that potassium and sodium are the very reactive, and gold and platinum, they're not so reactive, right? Do you remember all of these? That exactly thing is going to is going to be very handy for you in this chapter, everybody. So when the electrode in contact with their ions, they are arranged on the basis of the values of their standard electrode potential or standard oxidation potential, then we get a series, and that series is called as electrochemical series. In electrochemical series, do you think that you have to learn this whole thing? Everybody say this is your electrochemical series, this is also electrochemical series, this is also electrochemical series. Together, all the three of them, that is there in your NCERT. So many metals. Will you be able to remember it, everybody? No, right? You don't have to remember so many things. So what will you do? What will you do is, you will just simple, some certain things you will remember. And those simple, certain things is that lithium has the lowest standard reduction potential, guys. And because it has the lowest standard reduction potential, it's a good, strong reducing agent. Okay? Fluorine has, everybody, fluorine has the highest standard reduction potential, and fluorine, my dear student, is a strong oxidizing agent. Okay, fluorine has a strong oxidizing agent, everybody. Now look at it. See, lithium has minus 3.05, everybody. What is the value? The value is minus 3.05. That's the least, everybody. So this means that this is a good reducing agent. Okay. All right. And somewhere in the middle of the series, you will find hydrogen, everybody. You will find hydrogen, and hydrogen has a value of 0. So whoever is above hydrogen, everybody, so you can remember certain of them. Okay. You can remember some of them. Whoever is above hydrogen, they are going to be good reducing agent. Whoever is below hydrogen, or take a look at it. I think in your NCERT, the table starts from fluorine. Yes, the table starts from fluorine and slowly it comes to lithium. Is that not right, everybody? Let me know. I think in the table, as far as I remember, because I have been through NCERT long back. You know what? Let's check it out, actually. Let's check it out here. Yes, see, it starts from fluorine, and it ends at lithium, isn't it? So that means that here you have hydrogen. So whoever is below hydrogen, they are going to be good reducing agent. Whoever is above hydrogen, they are going to be good oxidizing agent. All right, everybody, remember this. Okay, remember this, everybody. Okay, all right, guys. This is clear. Electrochemical series, anybody, any doubt? For fluorine, it is plus 2.87. For lithium, it is minus 3 point something. Okay. For lithium, it is minus 3 point something. Am I clear, everybody? This is done. Easy peasy biryani tasty. Any doubt till here? Any doubt till here, guys? I'm waiting for you all. Any doubt till here, bachus? I'm hoping no. Nahi re Anurag, NCERT won't be enough for JEE completely. Okay, NCERT is enough for your inorganic chemistry, definitely. But NCERT is not enough for your physical chemistry and for organic chemistry. Not at all. You will have to do a lot of problem solving. So in physical chemistry, you can look at the concepts from NCERT because it's a very easy language. So yes, that will be very good for you. But the problems you will have to practice from, several different reference books, or what I will suggest is that this is there in your Amazon, guys. So you can get this book from Amazon, everybody. You can get this book from Amazon because this is for JEE Main, and you will get all the previous year question, everybody. All the 2022 and 2023 questions you will find in this book. That means that together for each and every subject, that is for physics, that is for chemistry, and that is for mathematics, you will be solving around 1380 questions. So that means that you will be solving around 4000 questions. So if you can get this book, it will be a lot of help. After NCERT, you can solve this book. Okay. then you don't have to buy several different reference books, and then you don't have to search for the questions, that where do I search how do I get the questions from. So this will be good for you. You can get this. Okay? All right. Acha. So guys, now moving on, the species that have a higher position in the EMF series or the electrochemical series, they have a higher reduction potential and lower oxidation potential. That means they can be easily reduced. That means they are good oxidizing agent. Okay. So fluorine is a good oxidizing agent. Fluorine is actually the strongest oxidizing agent, right? That's what I have told you. Now when we come to this elements at lower position in the EMF series or the electrochemical series, they have lower reduction potential. That means they have higher oxidation potential. That means they can be easily oxidized. That means they are good reducing agent, right? So lithium is at the bottom. That is why it is a very strong reducing agent. Okay? All right? Yes? All right. Yes. What are you saying? Oh wow, I'm so happy, Kabir. Thank you so much. 67 out of 70. Electrochemistry JEE weightage is 2 questions, definitely. So 8 marks you will be getting from electrochemistry. So guys, now that we are done with electrochemical series, can we do a solve a question, everybody? Thank you so much, Govardhan. Thank you so much. Please pay attention to the class now. Yo guys, everybody. Yo, everyone. Chalo. Batao, let's try and solve this question. What do you all say? Let's try and solve this question. So the question is, arrange aluminium, copper, iron, magnesium and zinc in the order in which they displace each other from solution of their source. The standard reduction potential values of the given metals are respectively as E naught for aluminium is minus 1.66 volt. E naught of copper is 0.34 volt. E naught of iron is minus 0.44 volt. E naught of Mg is minus 2.37 volt, and E naught of zinc is minus 0.76 volt. Now what have I just told you, everybody? Yes, what have I just told you? Haven't I just told you? I have told you right away, but choose that more the negative value of E naught, more the negative value of E naught, more will be the capacity to displace, isn't it? More will be the capacity to displace, isn't it? More will be the capacity to displace, everybody. So that means who has the negative? Who has the highest negative? Minus 2.37, that means magnesium. So we will write magnesium first. After that, who do we have? After that, we have minus 1.66. So that means aluminium. Yes. After that, who do we have? We have zinc is minus 0.76. So zinc here. Okay. After zinc, who do we have? We have minus 0.44. So iron here. Okay. And after iron, last but not the least is your copper. Yes, everybody. Does this make sense? Does this make sense, everybody? Yes. Yes, everyone. Surya, your answer. Roshni has already answered. Thank you, Roshni. Thank you so much. Oxidizing power is tendency to get reduced, and this does oxidize other element. Yes. Very good, aspirant. Very good. Yes, you guys have done it. Well done. Acha. Oh, this happens. Yeah. So every time I write something, then good only. Then I will not be giving you the exactly, solved answers. I will not be able to give you. Very good. You will be able to practice from this PDF only once again. These questions I'm solving for you. You guys will have to remember it and solve it on your own. Very good. Okay. So 2000, virtually 2000 you guys have won. 2000 rupees. You have won. Okay. Can you buy the book in offline center? I think so, Guna. I'm not very sure. But in Amazon, it is definitely there, So you can either buy it from Amazon or you can order it from Vedantu's website. Chalo. Guys, next question. The position of some metals in the electrochemical series in decreasing order or in decreasing electropositive character is given as magnesium first, then aluminium, then copper, then silver, right? What will happen if a copper spoon is used to stir a solution of aluminium nitrate? Guys, as per this series here, you can see that aluminium is more electropositive character, right? Aluminium has more electropositive character than copper, so that means that aluminium is more reactive than that of copper. So that means that if you dip a copper spoon, there will be no reaction because copper will not be able to replace aluminium. Is that right, everyone? So that means here there will be no reaction. So how many of you have won 4,000 rupees virtually? 4,000 rupees. Do you think that you will be able to get 1 crore today? Do you think that virtually you will be able to get 1 crore today, everybody? Yeah, I didn't know. No. How? Paglu. Roshni? Roshni, D bacha, D. No reaction will happen. Aluminium is more reactive than copper. Copper will not be able to replace aluminium bacha. More electropositive character aluminium has. No. Yes. So, acha. So, you guys did not get your money then. No. Now, 4,000 rupees cancel, guys. You have only won 2,000 rupees. Everybody is done from the hot seat then. Hot seat pe main बैठूंगा. Only I will sit in hot seat. You guys won't sit in hot seat. Check. At this easy question, you lost 4,000 rupees. Yes, D. Chalo, I'll give you another chance. You take 4,000 rupees, guys. Virtually, you take 4,000 rupees. What is good? I don't have anything lost. It's not me. It's not going from my pocket, so it's fine. Until and unless it's not going from my pocket, it's fine. So you take virtual 4,000 rupees. Everybody, each one of you take 4,000 rupees. Chalo, guys. Moving on to the next question is, Zn cannot displace following ions from the aqueous solution. Who cannot displace, sorry. Who can Zn not displace, everybody? Yes, Ag plus, Cu2 plus, Fe2 plus or Na plus. We all know that definitely sodium is going to be more reactive than zinc. However, silver is a borderline noble metal. We know that already, isn't it? Copper and Fe2 plus, all of them are going to be more reactive than Zn, because we also have read inorganic chemistry DNF block. Hence we know that copper and iron are going to be more reactive than zinc, but it's only sodium. It's only sodium. Sodium is so much more reactive that zinc will not be able to displace the following ions. Right, everybody? Yes, it is again D. Okay, it is again D. So now how much do you win? 4,000, 8,000 rupees. My God. Whoa. If only it was all true. If only the 8,000 rupees was true, it would be wonderful, isn't it? 8,000 in one day just by answering correct answer. Alrighty. Moving on. Next question, everybody. Yes. Next question. Guys, please tell me that you all are sitting with a paper and a pen. Yes, are you all sitting with a paper and a pen? Because I need you all to solve the question. If you don't solve the question, if you don't spend time enough in the question, it's not going to be a very great result, everyone. Okay. And even if you are not, once you get the PDF, promise me that you will be solving the question. I have a lot of questions and I'm going to give you homework, everybody. I'm going to give you homework. Now your board exams are over. You cannot give me the excuses, but ma'am, why are you giving you homework? We're not done. We have to study a lot. You can't do all of that. Okay, next question, everyone, is given the standard E naught, yes, K plus to K is equal to minus 2.93 volt, Ag plus to Ag is equal to 0.80 volt, Ag2 plus to Ag is equal to 0.79 volt, and Cr3 plus to Cr is equal to minus 0.74 volt. Arrange these metals in their increasing order of their reducing power, everyone. Okay, so who was it who asked me oxidizing power? Now, Bachu, can you... Now, can you define reducing power for me? Can somebody define reducing power for me? Until that time, let me tell you, the lower is the electrode potential. You can understand that stronger is the reducing agent. Now, who has the lowest? Who has the lowest, everybody? So, definitely it is going to be... It's not option D. No, it's not D. It's not this, okay? Let me write it down, everybody. It is K. K has the lowest, isn't it? K has the lowest minus 2.93. So K, then it is going to be next lowest is Cr, isn't it? Next lowest is Cr. then it is going to be Hg, right? And then it is going to be Ag. Yes, so that means I think option A is the correct answer. Guys, please check it out. Is option A the correct answer? Because here I think by mistake they have given the wrong this thing. Very good, Tanishka. Very, very, very good. Yes, very good. Why not D? D cannot be, no? D is ulta, isn't it? The lower the electrode potential, the stronger is the reducing agent. Arrange these metals in their increasing order of their reducing power. So who is going to be the greatest reducing agent? Because this has the lowest one, the K is going to be the greatest reducing agent, isn't it? Potassium will have a stronger potassium will be stronger reducing agent, right? Or not? Yeah, potassium is anywhere at the bottom, guys. If lithium is the most strongest, then potassium is the second last one. So potassium, it will be potassium. Minus 2.93. Roshni, do we understand? Yes, very good. Very, very good. Now, how much did we win, guys? 8,000. After that, 16,000. Bro, you're definitely getting some crores today, okay? All right, everybody. So electrode potential, standard electrode potential, reduction potential, oxidation potential, everything is done, everybody. Yes. Yes, Tanishka. Yes. Lower is the value. Lower is the value. It is stronger reducing power. Okay? All right. Yes. 16,000. Very good. Okay. So guys, just revising quickly. Till now, what are the things that we have completed? Till now, we have understood spontaneous and non-spontaneous reaction. We have understood Daniel cell, we have understood salt bridge, we have understood electrode potential, we have understood oxidation potential, we have understood reduction potential, standard reduction potential, and we are done with electrochemical series. Till now, everyone, are we done? Is there any doubt whatsoever? Yes? Are we done? Okay? Everything is clear, guys? Yes, now we come across something that is called as cell potential. Acha, we are talking about cell potential anyway, yes. Now, when we talk about cell potential, did you know that the cell potential can also be named certain things? We can call it as E cell, we can call it as electromotive force, right? But when does it become electromotive force, everybody? It becomes electromotive force when no current is drawn from the cell, everybody. When you are not drawing any current from it, at that time only it becomes cell electromotive force. Are you understanding? Yes or no? Are you understanding, everybody, what I'm trying to say here? Yes or no? I said something very important. That's why I'm asking you. No, Roshni, no. Fluorine is the strongest oxidizing agent, isn't it? Fluorine is the strongest oxidizing agent. And lithium is the strongest reducing agent. So if it is more negative, it is going to be strong reducing agent. If it is more positive, it is going to be strong oxidizing agent. Yes, more negative the value, more reducing agent. Stronger reducing agent it will be. More positive, stronger oxidizing agent. Roshni, are we clear now? Or do we still have a doubt here? Roshni? We are clear, right? Yes? No doubt here? I feel like there is a bit of confusion here, everybody. Clear na? Chalo, okay, alright, yes. So we are talking about cell potential. The cell potential can also be called as cell electromotive force. It can also be called as E cell. What is cell potential, guys? When we talk about cell potential, it is basically nothing. In a layman's term, we can say that it is the potential difference between the two electrodes of a galvanic cell. See, just before this, we were talking about electrode potential. That means the zinc rod with zinc sulfate solution, copper rod with copper sulfate solution. Now, when we talk about cell potential, we mean that the zinc rod, zinc solution, copper rod, copper solution, This, what is the difference? That is your cell potential. Okay, how do you measure cell potential? You measure the cell potential in volts. That is the unit. It is called as E cell. And the time when you are not drawing any current, that means you are not taking away any current, that is when it is called as the cell electromotive force, everybody. Okay, that is when it is called as cell electromotive force. So cell potential, that is E naught cell, is basically your oxidation potential of anode plus reduction potential of cathode. Okay, or you can write it as E naught ox of anode plus E naught reduction of cathode. That means that we can also write it as E naught cell is equal to, because we know that IUPAC, Big Daddy of Chemistry, has told us that we are only going to take reduction potential. That means that reduction potential of cathode minus reduction potential of anode. So E cathode minus E anode is going to give us the cell potential, or we also can write it as oxidation potential of anode minus oxidation potential of cathode. That means E anode minus E cathode. That is also possible. All right, everybody, is this clear? Is this clear, everyone? Yes. Now, EMF of the cell, it should be positive. Otherwise, it will not be feasible in given direction. If it is not positive, by chance if you find a negative, if you find a negative EMF, that means the reaction is not feasible. Okay, that means that in that direction it is not feasible. Okay, product of electrode. Sanjay, I'm not very sure, but in this slide I have it and I'm going to teach you. Okay, don't worry about it. I'm going to teach you. Okay, Alaska, if you are late, no worries. You can watch the session from the very beginning once I'm done with the session. Me online, yes, I will give you the notes, but the notes will be given in the Telegram channel. So do join the Telegram channel. Okay. All right. So I've just told you, everybody, why do we call E cell as cell electromotive cell, or when do we call it? Because when no current is drawn through the cell, at that time we call it as cell electromotive force. Clear, everybody? Now guys, one very important thing, that is standard hydrogen electrode, or SHE. I mean, it's not very important from the perspective of a JEE question, but it is very important that you know this. Okay? But it is very, very, very important that you know this. So standard hydrogen electrode, that is SHE, everybody. Do you remember, guys? Do you remember, everybody, that hydrogen had standard reduction potential to be 0? Yes, everyone. Do you remember? So that means that it can act as any of the electrode. It can act like an anode, it can act like a cathode, and that is why we take it as a reference electrode. Okay, what do? We take it as a reference electrode. So what we are doing is, we are going to take 1 molar, okay, we are going to take 1 molar H plus ion. So 1 molar H plus ion, that means 1 mole of hydrochloric acid we can take, right? Or 1 mole of 1 molar dilute sulfuric acid, if we take, we can do that also, right? Yes. And then what we will do is, we will have a glass bar. Okay, we will have a glass, right? We will have a glass bar. In that there will be a metallic wire, and then that metallic wire, it will be covered with a platinum foil. Sorry. In that we will be taking a in that we will be taking a platinum wire at the bottom, right here. See, right here. Do you see? It will be platinum foil will be covered by a porous platinum. You will cover it. Okay. All right. And through that glass, that glass inverted tube kind of thing, through that you will be pushing some hydrogen. The question that may come in your mind is, ma'am, why are we taking only platinum? From a very, very, very young age, don't we know that platinum is what? Platinum is a noble gas, but that's not the reason. The reason is that platinum can absorb hydrogen. Okay, what can platinum do? Platinum can absorb hydrogen. So at the cathode half cell, okay, so basically what is happening is, hydrogen, that is H2, you are taking H2, H2 is getting converted to 2H plus ions, right? So that means the cathode half cell reaction is H plus. H plus is gaining 1 electron and it is forming half H2, because 2H plus, so 2H plus can also be written as half H2. Am I right, everybody? Am I right, guys? Yes, absolutely. At the anode half cell, what is happening is, half H2 is getting converted to H plus. That means it is losing electron, right? It is losing electrode. Yes. So oxidation is happening here. That means that at anode right here, this is the oxidation reaction and this is the reduction reaction. All right, everybody. Yes, guys, are we clear? Now, I have just told you some time back that it can act as a reference electrode and it is 0. So, E naught, when it is going from H plus to half H2, that means when it is getting reduced, E naught is going to be 0. When it is getting oxidized, it is still going to be 0. Okay? Alright? Yes. Okay, everybody. Now what we are going to do is, let us try to measure the electrode potential of zinc. See, I remember I told you that we will have a voltmeter here and we will try to use SHE to find out the reading, find out the electrode potential of zinc, everybody. So the chart that you saw in the electrochemical series, everybody, guys, pay attention. The chart, in that chart, everyone, now can we please find out NCRT, nikalo NCRT, everybody take out NCRT and tell me what is the value for zinc, everybody. What is the value for zinc, guys? Zn2 plus 2 electron forms Zn, right? Yes, forms Zn, and that value is minus 0.76, everybody. Minus 0.76. See, I'm going to tell you, okay? I'm going to tell you. See, look at it, everybody. So we know that E naught oxidation potential is going to be 0. E naught reduction potential for standard hydrogen electrode is 0, right? So what we are going to do is, we are going to use the zinc rod here as cathode and we are going to use the hydrogen, that is SHE, as anode here. Okay, everybody? All right. Okay, and here you have the voltmeter, guys. Here you have the voltmeter. Do you guys see, everyone? Yes, here you have the voltmeter. Now what will happen is, so we know that E naught cell will be equal to E naught Rp of cathode minus E naught Rp anode. At the cathode we have the zinc, right? At the cathode we have zinc, so that is the notation that I have used. Anode mein we have the hydrogen electrode, so we have used this notation. Now for hydrogen it is 0, that means the E naught cell is equal to E naught reduction potential of the cathode. What is the cathode? Cathode is the zinc rod, everybody. And then the voltmeter right here, that will deflect. The voltmeter will move. It will give you a reading. That reading, my dear student, is minus 0.76, which is exactly what is written in the series. Also correlate the value, everybody. So just like this, by using this standard hydrogen electrode, for each and every element that you see in the series, we have calculated the E naught value. Correlated, everybody. Did you see it? Minus 0.76 volt. That is exactly the value that is written in your book. Is it true or not? Yes, is it true or not? Similarly, if you take in the cathode, if you take copper and if you take anode here, then again you can, then you can find the E naught value for copper. Similarly, you can do it for each and every element, everyone, and that is how we came up with this series. Is this clear? Any doubt here, guys? Is standard hydrogen electrode clear to you all? Is standard hydrogen electrode clear to you all? Is there any explanation that you need here more? Any other explanation that you need here more? No, Baba. No. Okay. Very good question, but very good question. I'm super happy with you. Super happy. So guys, Tanishka has asked us a question that Tanishka has asked us a question. Ma'am, you told zinc does not undergo reduction. Then how can it be in cathode? Very good. So here, bacha, do you notice that the value here is minus 0.76? What is the significance? What is the significance of minus 0.76? The fact that there is a minus 0.76, that means that here hydrogen is more stable than the reduced form of zinc. Hydrogen is more stable than the reduced form of zinc. That means that Zn2 plus to zinc, that conversion, that reduced form we will not get. Zn can get to Zn2 plus form, it can go to its oxidized form, but the reduced form we will not be getting. That means a metal which has a less stable reduced form, it will not undergo reduction. This is the significance of this minus, bacha. Yes, but it will go through oxidation, of course. Yes, it will get oxidized on its own and it will become a good reducing agent. That is the significance of minus 0.76. Now use the same thing. Do the same thing. Take copper as a cathode. See what is the value you will be getting. If you take copper as the cathode, you will see that value is plus 0.34. That value is plus 0.34. The voltmeter reading will only be plus. That means that copper likes to stay in its reduced form, but zinc likes to stay in its oxidized form. Got it? Clear? But very good question, Tanishka. I'm so proud and so happy that you are paying attention and you have asked me this question. So, bacha, now are we all clear with our zinc? Repeat again. Chalo, I will repeat again. So, the question was, Tanishka has asked me, everybody repeating it again, please listen to me, everyone. Tanishka has asked me a beautiful question. And the question is, ma'am, you told zinc does not undergo reduction. Then how can it be cathode? See, once again, everybody, let me explain. Hydrogen, standard hydrogen electrode, that can be a reference electrode. It can act like an anode, it can act like a cathode. Why have I taken it as a cathode here? To show you this. To show you this. When we measured here, the voltmeter reading came up as minus 0.76, isn't it? This is the reading, right? Minus 0.76. The question was, why is there a minus? What does this minus, what does this negative sign signify? This negative sign signify that zinc in its reduced form is not stable. That means zinc actually will not be the cathode, but you will have to place it in anode. If you place it in anode, you will get plus 0.76 as the reading. You will not get minus at that time. If it is showing minus, that means it is not stable in its reduced form. That means it will not undergo reduction. It will undergo oxidation. It will अपने आप को, that means खुद ही अपने आप को, it will by itself oxidize himself. Zinc will oxidize himself and it will be a good reducing agent, but not reduce itself. It will oxidize itself. Gotcha? Clear, everybody? Yes, Bharat? I hope that now you are all clear, everyone. Are we all clear with this? Any doubt here? Any doubt here, guys? Any doubt here, everybody? Are we all clear with this? Yes. Quickly go ahead and let me know. This is the negative significance. Yes. If you do the same experiment with copper, right? If you do this exact same experiment with copper, you will find that copper here, yes, copper here will do what? Copper will show you a positive sign. Ma'am, can you explain full now this topic? What am I doing, guys? Am I dancing? Like Pink is asking, can you explain full now this topic? Am I not explaining this full topic? I think this is the most basic that I can go. I can't go beyond this basic, then I'll have to teach you from, 8th standard. Not only zinc has this tendency, bacha. So if you take zinc or if you take aluminium, okay? If you take aluminium in the cathode, you will find that again aluminium will also show minus, okay? If you take lithium in the cathode, lithium will also show you the negative sign. If you take potassium, potassium will also show you the negative sign, okay? All right. But look at copper, everyone. Copper is on the top, isn't it? Yes? Copper is above H plus. Copper is above H plus, everybody. So copper here, my dear students, what does it have? It has a positive sign. That means copper can act like a cathode. Whoever has this negative sign, they are not going to act like a cathode. They are going to act like an anode actually. That's the significance of the negative signs. Clear? Hey? Yes? Shall we move on now, everybody? Shall we move on? Check. Now we come across something that is beautiful, something that we have to understand, and that, my dear student, is the relationship between delta G and E naught cell. Tell me, where have you read this? You all have read it in your thermodynamics chapter, everybody, if you remember. Yes, everyone, all of you have read it, isn't it? Yes. So what do we have? We have delta G is equal to minus NFE cell. Okay. Yes. Delta G is what? Gibbs free energy. What is delta G naught? Delta G naught is standard Gibbs free energy. Alright, what is N? N is the number of electrons that are getting exchanged. So remember how Zn was giving away 2 electrons. See, 2 electrons exchange was happening, right? Copper was grabbing hold of 2 electrons. So there is an exchange of 2 electrons. So that will be the N value. What is F? F is your Faraday's constant, and the value of F is usually 96500 coulomb. That is the value of 1 Faraday. Alright, everybody. Yes. Now there are certain conditions for the spontaneity of reaction. What are the conditions? The conditions are when delta G naught is negative, E cell will be positive. Why? Look at the sign, no, everyone. Yes, look at the sign. If E cell is positive, only then this negative sign will be accepted. That means that delta G naught is going to be that means that delta G is going to be negative. If delta G is negative, that means it is going to be a spontaneous process. Okay. If delta G is positive, that means that E cell will have to be negative, because see, here is a negative sign. So if E cell is also negative, then negative will become positive. If delta G is positive, then we know from thermodynamics that this is going to be non-spontaneous, everybody. And if both of them are 0, that means that is going to be at equilibrium. Yes, everybody. Are we done? Clear hai? Any doubt here? Any doubt till here, guys? Any doubt till here? Yes, we are all clear with everything that I've taught you. Acha, now here is the typed form, how you can calculate calculation of electrode potential of unknown electrode with the help of given 2 electrodes. So basically, let's say that now that is Gibbs free energy and E cell, relation between Gibbs free energy and E cell, bacha. Nernst equation we will come, okay? We will come to Nernst equation, don't worry about it. Chal. So here what we are doing is calculation of electrode potential of an unknown electrode. Let's say that we have an electrode and we do not know what is the potential of it. But we also have given 2 electrodes. So how do we calculate it? Yes. First of all, what we will do is we will obtain the reaction of the third electrode. Okay. Alright. With the help of some algebraic operations. So we will use some, we will use some techniques, like we will make some algebraic equations and we will take 3 equations. So we will have a third equation. Then we will calculate the delta G naught of the third reaction with the help of some algebraic equation that has the first and the second reaction. Okay. Then we will use this formula, that is delta G naught is equal to minus NF E naught cell, and we will calculate the unknown electrode potential. Then we know that E naught cell is an intensive property. So we will multiply or divide it by the electrode reaction by any number, and the E naught cell value will not change. Alright, everybody. Yes, guys. So check it out, everyone. If you have Zn2 plus 2 electron forms Zn. And if you have 2 Zn2 plus 4 electron multiplied with 2 Zn, you will see that the E naught value for both of them, it is minus 0.76 volt, because it is an intrinsic property and the value will not change, everybody. If you did not understand, let's solve a problem. I think you will all be able to understand this. Shall we solve this problem, everybody? Chalo, let us solve this problem, guys. Here we are. Let us solve this problem, guys. Yes. What is given to you? See, you are given that E naught. Okay, one second. You are given here. Actually, you know what? Let me take a page here. Let me take a blank page here and solve it for you. Okay, everybody? Are you all here with me? Everyone, are you all here with me? Which way should I go? Which way should I go? I think this way is better, isn't it? This way is better. Chalo. Yo guys, are you all with me? Chalo, let us solve it. Okay, what are we doing? See, E naught value is given. The number 1 is, see, Cu2 plus to Cu, right? Cu2 plus to Cu. What is the value? It is given as 0.337. 0.337 volt. Consider this to be equation 1. Okay, everyone? Let's try and solve it. Okay, whatever I've told you, how to calculate the third potential. If you do not know, it is an unknown electrode potential, you do not know how to calculate that, let's solve this and let's try to figure it out. Everybody, are you all here with me or no? Next, what else is given, guys? What else is given is E naught Cu plus to Cu2 plus. Okay, E naught Cu plus to Cu2 plus. That value is given to you as minus 0.153. Minus 0.153 volt. Okay. Alright. So let us consider this to be as equation 2. The third one is E naught Cu plus to Cu. Okay. Third one is E naught Cu plus to Cu, everybody. That means the reaction, what is going to be the reaction, everybody? The reaction here is going to be Cu plus 1 electron. If you gain, then it is going to form Cu, isn't it? And here we do not know the third E naught value, right? We do not know the E naught 3 value, isn't it? That's what we have to calculate. Correct, guys? Yes. So that means everyone, everybody, that delta G3 naught is equal to delta G1 naught plus delta G2 naught. Okay, let's add. We are adding equation 1 and equation 2. Okay, from here, so delta G is equal to minus NFE, right? We know that. So what we can write here is minus N3, or not even N3. Why write N3, everybody? Chalo, let's not write N3. Let's write N. Let's write minus NFE3. Okay, minus NFE03 is equal to minus NFE1 naught plus minus N2. Why did I write N2 again? 1 second. Sorry, guys. Minus NFE02. Correct, everybody? Yes. Now from here, everyone, what we can do is E3. So we can cancel all the N and F. N and F are what? N and F are going to be the same thing, everybody. No. We can only cancel F, everybody. We cannot cancel the N, because N is going to be different. See, Cu2 plus to Cu, that means 2 electrons here. Cu plus to Cu2 plus, that means 1 electron here. Cu plus to Cu, that means again 1 electron here. So we cannot cancel all the N. We can only cancel the F, everybody. Okay. So that means that our E3 is going to be minus N. Oops. Sorry guys, my pen has gotten discharged, everyone. Can you guys try and do this question, everybody? Quickly try and solve it and tell me the answer. Try and solve it and tell me the answer, everyone. So here what will we write? We will write minus NFE1 naught plus minus NFE2 naught divided by minus N3F, let's write. Okay, N1, N2, N3. Okay, F can be cancelled from everywhere, right? F we can cancel, this and this we can cancel it, everybody. Correct? So from here, now see, minus N1. N1 is going to be 2 electron, because see, 2 electrons, Cu2 plus to Cu, right? So 2 multiplied with 0.337, yes, plus minus we have 0.153, everybody. Okay. So if you calculate this, how much is the answer that you are getting, everyone? Let me know. How much is the answer that you are getting? How much is the answer that you guys are getting, everybody? Let me know. 2 into 0.337, that means 2 multiplied with 337 is 0.674. Yes, minus 0.153, that will give you 431,752,615, 0.521 volt. Is that right? Yes, 0.521 volt. That means option C is the correct answer. Option C is the correct answer. Is that right, everybody? Option C is the correct answer, correct? Yes. Option C is the correct answer. Very good. Very, very, very good. Chalo. Next question, everyone. The next question is, everybody, check it out, guys. Check it out. The standard Gibbs energy for the given cell reaction in kilojoule per mole at 298 Kelvin is Zn plus Cu2 plus forms Zn2 plus Cu. E naught value is equal to 2 at 298 Kelvin. Faraday's constant is also given to you. Very good, everybody. Very good. Yes, you guys are answering. Achha. So what we can do is, chalo, once again, let me try and solve. Okay? Let me try and solve. One second, guys. My laptop is getting this thing. Sujal, you are late to the class. Please watch the class from the beginning. I think you will be able to understand then only, okay? Okay, so here what are the things that are given to you? See, N you can find out that it's 2 electrons. So N is equal to 2, right? Yes, E naught value is given to you as 2 volt, right? Faraday's value is given to you 96000 coulomb per mole, isn't it? Yes, very good. Now what is it that we know? We know that delta G naught is equal to minus NF E naught cell, right everybody? Minus NF E naught cell, that means that, so minus 2 multiplied with 96000 multiplied with 2 volts. So 2 into 2 is 4. 4 multiplied with this will be 4 6 4 5 24 6 24 2 4 9 36 37 38 38 384 000 joule per mole. That means it is going to be minus 384 kilojoule per mole. So I think it is option A. Is that right, everybody? I think it is option A. Is that right, everyone? Yes or no, guys? Very good. Chalo. Done, 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 done. Done, 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 everybody. Chalo. Let us move forward, guys. Let us move forward. Now we are going to come across something that is called as Nernst equation. Shall we do it, everybody? Chalo. Yes. Yes. Let us take a look at Nernst equation, everyone. Nernst equation, guys, is, chalo. Again, I'm going to write it here, okay? I'm going to write it here so that you all can see it and you can make a note out of it, okay? Yeah. So everybody, we all have just studied, right, that delta G is equal to, everyone, you tell me that in your thermodynamics chapter in class 11th, haven't you studied that delta G is equal to delta G naught plus 2.303 RT log base 10 here Q. What is Q, everyone? What is Q, guys? Q is called as reaction quotient, isn't it? What is it called as? Reaction quotient. Very good. Okay. Now we have just studied that delta G is equal to minus NFE cell. That means that I can write it as E cell is equal to E naught cell minus this 2.303 RT log RT. Okay, this if I just calculate it, then what will I get? I will be getting minus 0.059 divided by N. Okay, divided by N log base 10. Okay, log. Sujal bacha, please yaar, class में पहले आया करो. You must come a little early. I've already taken it a lot forward. You are halfway done. Watch the video from the beginning. You will understand what is cathode, what is anode, what is E cell, what is E naught cell. Okay? Now you are at the middle of the class. We have already moved a lot ahead. If I try and explain it to you again, it's going to be a lot of time. Okay? Please watch it from the beginning and catch us up a little later. Okay? Alright, bacha? Thank you so much, Sujal. Thank you so much. Okay, log base 10. Let me write Q here again. Can I do that? Very good. Very good, everybody. Now this Q that I have written, suppose I have a general form of reaction which is, suppose I have a general form of reaction, my dear student, and that is AA plus BB, which forms CC plus d d. Okay? Alright everybody, what if I have this? If that is what I have, then my dear bachos, what happens to Q? My Q becomes, Q is equal to capital C raised to the power C multiplied with capital D raised to the power D divided by capital A raised to the power small letter a multiplied with capital B raised to the power small letter b. That means that it is numerator pay, you have the numerator pay, you have the product, and at the denominator you have the reactants, everybody. Okay, at the denominator you have the reactant, and by chance if you have a solid, then the concentration of the solid will become unity, and if you have a gas, then you will not be taking the concentration, you will be taking the pressure, and that, my dear student, is your Nernst equation. Okay, that, my dear student, is your Nernst equation. If you ask me that, ma'am, what is going to be the Nernst equation for the Daniell cell? Remember the Daniell cell that we did? For that, the Nernst equation is, everybody, going to be, let's say that E cell is equal to E naught cell minus, you can write it as minus RT divided by 2 electrons were exchanged. Do you remember? 2 electrons were exchanged. So here we are going to write 2 multiplied with Faraday. Let us take natural log here. If we take natural log here, that means what was on the product side, everybody? Product side, you are getting Zn2 plus. Isn't it? You are getting Zn2 plus divided by reactant side, you had Cu2 plus. And this is going to be the Nernst equation for the Daniell cell. I hope it is clear to you all. Yes, I hope that it is clear to you all. By the way, the question that comes in your mind is, ma'am, why do we have Nernst equation? All this time we were talking about reduction potential, we were talking about E naught cell, we are talking about E cell. All of that is fine, but why Nernst equation? Because bachcho, science hai, chemistry hai, right? Reduction potential, standard reduction potential, they were all for 1 molar concentration, 1 bar temperature, 298 Kelvin. What if we are given certain kind of reaction where it is not standard? What do we do then? And that is when the Nernst equation comes into our picture. That is when Nernst equation helps us. Now there are obviously some there are some applications of Nernst equation, everyone. Okay, and those applications, let us have a look at it. But before we understand this, let me just tell you that Nernst equation can also relate your concentration with temperature. Yes, so have a look at it. Effect of concentration on E cell. Sorry, what did I say? Effect of concentration on temperature? No. Concentration and temperature can affect EMF, and that is what Nernst equation gives you. So what case one is, if there is a standard condition given, like concentration is 1 molar and partial pressure is 1 atm, then your reaction quotient is going to be equal to 1 and your E cell is going to be E naught cell. If it is equilibrium, at equilibrium, now somebody has come up, yes, if it is equilibrium, at equilibrium, what happens, guys? At equilibrium, your reaction quotient becomes KEQ. And you all know that at equilibrium, your delta G is equal to 0. That means that your E is equal to 0. So at equilibrium, E will become E naught minus, sorry, your at equilibrium, you will get this formula basically. Okay, what will you get? You will be getting this formula. Sorry, again, I'm not able to write because, you know, my pen charge has gone, everybody. So here what will you be getting? Your E naught is going to be equal to 0.059 divided by n log KEQ. What is KEQ, everyone? KEQ is equilibrium constant. Clear here, guys? Any doubt here? Nikhil, I think so. Yes, I think so, because our courses are designed in such a way that I think you will be able to do it. Okay, this reaction is important, everyone. This particular equation, I think you all can put a line here and do remember it. Okay, yes. Now you will be asking me that, ma'am, we are doing Nernst equation, but it's such a weird reaction, we don't like it. I know, even I don't like it. You know, I've told you in the previous class also that Pahul sir, you know, you guys know Pahul sir? Yes, the one who teaches in Vedantu JEE Hindi channel. Yes, he's a phenomenal chemistry teacher. He has been teaching chemistry from a very long time. In fact, a lot of things that I have spoken to him before the class, I also asked him, whenever I used to go to office, I used to sit and discuss with him that how do I take this session, what examples can I give them, a sort of like, these things. So yeah, he's a great chemistry teacher. Every time we talk and we, the Nernst equation comes up, we are like, why is this reaction there? Both of us, we don't like it. I don't like it at all. So yes, this question may definitely arise in your mind that, ma'am, why are we studying Nernst equation? Because it does have application, and the application is that you can figure out the EMF of the cell. Yes, you can figure out the EMF of the cell, right, at a given concentration. At any given concentration, you can figure it out. You can find the equilibrium constant for a reaction, which I've just told you, right? And you can also calculate Gibbs energy of a reaction. Okay, you can also calculate Gibbs energy of a reaction. How do you do that, everybody? Delta G is equal to delta H minus T delta S, and I've just told you that it is. Okay, let me write this down here, everybody. Let me write this down here, writing it down here for you all. So you all know that delta G naught is equal to minus NF E naught cell, isn't it? You all know this, right? Now, what is E naught cell, guys? E naught cell is equal to NF RT ln Kc. Just showed you, equilibrium constant. Just showed you equilibrium constant, isn't it? So that means I can also write it as delta G naught is equal to minus RT ln of K. Why so? Because E naught cell can also be written as NF RT ln Kc. Correct, have a choose? Yes. So this is how you can calculate the Gibbs free energy. Game over, you like? Seriously? Thank you, Monisha. Thank you so much. So yes, we are done with Nernst equation as well. My God, we're going so fast, everybody. Acha, now everybody, there comes a picture which is there in your, is it there in your NCERT? I don't think so. Types of electrode is probably not there in your NCERT, but here is a chart. If you want, you can go through this. Okay, yes, if you want, you can go through this. So there are different types of electrodes. You have a metal ion, metal and the metal ion electrode, which can be noted as Mn plus, that is Zn to Zn2 plus. Remember those kind of electrode? Yes. So here the half cell reaction can be noted like this, and the electrode potential for reduction. So here I have basically, it's a table that gives you the electrode potential of different types of electrodes, everybody. Okay, with different types of electrode. You gave written reciprocal. Where? Acha, this one. This one. This is the one that you're talking about, that I just wrote. I'll write this again, okay? I'll write this again because it seems like it went off. Sorry, I'll write this again, okay? How do you do this? So everybody, we all know that delta G is equal to minus NFE cell, right? Yes, okay? Now we also can write this as delta G naught is equal to minus NF E naught cell. Am I right, everybody? Yes. Now E naught cell can be written as, what can E naught cell be written as, guys? E naught cell can be written as at equilibrium. Yes. E naught cell at equilibrium can be written as, but that's the correct answer, because I am taking natural log, na bacha. See, the difference is here it is log. Here it is log base 10. Here I am taking natural log. That's why. That's the only difference. Yes. So here E naught cell is going to be equal to N multiplied with F divided by RT ln of Kc. Okay. This is your natural log Kc. So from this equation, from this derivation, here what I can write is that delta G naught is equal to minus RT ln of K. Why so? Because see, check it out, everything is clear, hai na? Right from here also you can see E naught cell is equal to NF divided by RT ln of Q. Check it out everybody. Is there any mistake or not? I don't think so there is a mistake, but let me know if there is. F is your Faraday's constant. Delta G is your Gibbs energy of the reaction. Delta G naught is standard Gibbs free energy. Yes. What is E? E is the EMF of the cell. What is N? N is the number of electron. Yes. Everybody? All clear? Check it out. Check it out. Is there something that is missing out? Something that we are missing out on? I don't think so. Very good. Game over, Tamil Gaming. NFE is equal to RT ln. No. It's not wrong. You check it out, guys. No. See, my NFE. Okay. NFE is equal to RT ln Kc. Right? Yes, everybody. Now, oh, guys. What are you saying? Check it out. So NFE is equal to RT ln Kc. Am I right? Yes. So that means that E is equal to RT divided by NF ln Kc. But from here, if you calculate E naught cell is equal to delta G naught divided by minus NF. Am I right here, everybody? Yes, guys. Now please check it out once again. I don't think there is anything wrong, everyone. Chalo, 1 second, wait. I've written it reciprocal, is it? It is minus RT ln of K. Delta G naught is equal to, this is what it's supposed to be, no? Wait a second. E is equal to RT ln of, okay. No, that box thing is not wrong. That box thing is only not wrong, guys. Arre. See, delta G naught is equal to minus NF E naught cell, right? If E naught cell is equal to delta G naught divided by minus NF. So from here, what can I do? From here, from this case, I can see E naught cell can be written as, E naught cell can also be written as, see, NF divided by RT ln of Kc. Why am I doing this? Why am I doing this? It's just an added on step that I have showed you. I still can't figure it out though. Wait a second, guys. Let me check it out. NFE is equal to RT ln of Kc. Wait a second. Okay, let's remove this. Have I done a mistake in the derivation? Okay, now let's see. NF is equal to RT ln C. So E is equal to RT by NF ln Kc, right? So if I put this in, delta G naught is equal to minus NF E naught cell divided by E naught cell, right? One second. Got it. Instead of writing E cell here, if I write RT divided by NF ln Kc, NF will cancel out. So delta G is equal to minus RT ln Kc. Does this make sense now, everyone? So that means that, now does it make sense, everybody? Is this clear? See what I did. Now see what I did, what I have done. Now see what I have done. Now check it out, what I am telling you. Now is this clear? Yes, everybody, check it out, check it out, check it out. Now is it clear? So delta G is equal to minus NFE cell, and we know that NFE is equal to RT ln Kc. That means E cell is equal to RT by NF ln Kc. This value I have put it here instead of E cell. Then I have simplified it and I get delta G is equal to minus RT ln Kc. That means that standard Gibbs free energy is also going to be delta G naught is equal to minus RT ln K. Am I right? Is this clear now? Everybody, check it out. Check it out, guys. Is everything clear now? Yes, just substitute the value of G. That's what I have done. Now check it out. Tell me. Check it out, guys. Yeah, Tanishka, I have done that only. See and let me know if everything is clear now. Please check, everybody. Please check. Quickly, let me know. So now it is clear? Now is it clear? Clear hai? Everything is fine? Yes, Tanishka. Okay. Aspirant, redox, and who else was it? Who else was it? Game over. Now is it fine? Now is it fine? Yes. Okay. Chalo. ठीक है. So here, as I was telling you that there are different types of electrode, and for each one of them here is a cheat sheet, and you can find the electrode potential. Now, I know that in your board examination, in your NCRT, this is not there. You do not have calomel electrode. You do not have metal insoluble salt anion. You do not have oxidation reduction type electrode. This is not there in your NCRT. I'll be providing you with the PDF. Don't worry about it. But do have a look at the electrode potential, reduction electrode potential ke equation. Very important. Okay. Alright, everybody, this is clear, guys. Yes, shall we move on? Chalo, let us move on and let us solve some more question. Here is a question for you, and the question, everybody, is, the question is asking you that the standard oxidation potential, okay, the standard oxidation potential of zinc is 0.76 volt, and for silver it is minus 0.80 volt. Calculate the EMF of the cell at 25 degrees Celsius. Yes, 25 degrees Celsius just reminded me. I do not think that I have told you, everyone, where is Nernst equation. Yes, guys, this equation right here that you see, this equation right here, this is applicable for 25 degrees Celsius, by the way. Okay, this is applicable only during 25 degrees Celsius. I'm sorry, I skipped it. Okay, now let us move on and let us solve this question. Okay, so the question, everybody, as you all can see right here, the standard oxidation potential of zinc and silver is given. Calculate the EMF of the cell at 25 degrees Celsius. Okay, and the reaction is also written. Okay. So the cell reaction, everybody, the representation of the cell is given to you. So what is the cell reaction going to be? By looking at the representation of the cell, you can understand that the reaction is going to be Zn plus, see, AgNO3, right? AgNO3 to Ag it is forming. That means 2Ag plus, okay, 2Ag plus will give us 2Ag plus Zn2 plus. Am I right, everybody? Great. Now what is given to you is, you are given E0 oxidation potential of zinc, okay? E0 oxidation potential of zinc is given to you as 0.76 volt. Am I right, everybody? Very good. Okay. 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 All right. and you have E naught reduction potential of silver is given to you as okay, so this is oxidation potential, guys. What is given to you as oxidation potential? If oxidation potential is minus 0.80, that means the reduction potential is going to be 0.80 volt. All you are going to do is change the sign. Okay? Okay. Now what we are going to calculate is, we are going to calculate the E naught cell. E naught cell is equal to 0.76 plus 0.80, that means it will be 6 and 7 plus 8 is equal to 5. So 1.56 volt, everyone. Is that right, guys? Yes? 1.56 volt. Very good. Now we have E cell is equal to E naught cell minus 0.0591 divided by n log of, we know that what do we take on the top? On the numerator we always take the product, and the denominator we take the, yes, on the denominator we take the reactant, isn't it? So if that is the case, then we can write it as 1.56 minus 0.0591 divided by 2 log of, what is given to you? Product 0.25 molar. So we will write it as 0.25. Great. 0.1, but here remember we wrote 2 is the stoichiometric coefficient. So we have to raise it to the power 2, right? So that means 0.1 square. Okay. Alright. Now everybody, can you calculate and tell me? Yes. Now everyone, can you tell me, calculate and tell me 1.56 minus 0.0591 divided by 2 multiplied with whatever you get, and calculate and tell me, everyone. Calculate and tell me. Come on. Yes. Come on. Tell me the answer. Calculate and tell me what is the answer, everybody. What is this log versus, and then tell me the correct answer. I think you should be able to do it and we can move on from here, right? I do not need to solve this, I hope. I do not need to solve this, I hope, for you all. Yes? I think it's just calculation. You all will be able to do it. Thank you so much. Tanishka is saying 1.51. Is it 1.51 volt, everybody? If Tanishka is saying 1.51 volt, I'm writing it down. But you guys, please check it out. Okay? Chalo guys, we will go to the next question. And this is a JEE Mains 2019 question. The question is, given is the equilibrium constant Kc of the reaction Cu plus 2Ag plus provides Cu2 plus 2Ag, everyone. Okay? 10 into 10 to the power 15. Calculate the E naught cell of this reaction at 298 Kelvin. Acha, 10 into 10 to the power 15. Okay. So what do you do? What do you do? Very simple, very easy, everybody. E naught cell is equal to, we know the formula, 0.0591 divided by n log Kc. Can we write this? We can write this, isn't it? We can write this, everybody? Yes, very good. That means 0.0591 divided by 2, and log of Kc is given as 10 to the power 10 multiplied with 10 to the power 15. That means it can be written as 10 to the power 16, and here will be log. Am I right? Yes. Now calculate this and tell me what is the answer. Who is asking, ma'am? E naught cell is reduction minus oxidation. Game over, Tamil gaming. Bacha, in the beginning, I have given you 3 formulas for E naught cell, right? Yes. 3 formulas for E naught cell, isn't it? Please, can you check it out? I do not have anything to check. Vitesh, I do not have. I think it should be minus 1. It should be 1.51 volt. I do not have the calculator. I did not calculate it, but I think it should be around that much only. Okay? Yes, guys, what are you getting? 0.47, no, they will not provide you log value. You must remember some of the things, okay? 0.4728, that means that I think option C is the closest. So we will write option C, yes? Option A has a millivolt, so option A will not be right, okay? Yeah, 0.4728. So yes, 4736 volt, we can write that. No worries, okay? Next, everybody, is E naught for the electrochemical cell is blah 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 is 1.10 volt at 25 degrees Celsius. The equilibrium constant for the cell reaction is, you need to calculate the equilibrium constant. Once again, everybody, I hope that you know the formula. What is the formula? E naught cell is given to you as 1.10 volt, isn't it? Yes, now we know that equilibrium constant. For equilibrium constant, what is E naught cell? E naught cell is equal to 0.0591 divided by n log of k. Am I right, everybody? Yes, absolutely. ये देखो, हर्ष निकेश जलकोटे. Again, can you please use smart board? Give me 5 lakh rupees, I'll put it up on the home. I'll definitely put it up. Can you give me 5 lakh rupees? I do not have 5 lakh rupees. No, I do not have. If you have, you give it to me. Tomorrow only I'll put up a smart board. I have no problem with the smart board. But if you have 5 lakh rupees, then tell me. Otherwise, in the studio also, there are a lot of teachers in the office. Everybody cannot get the studio at the same time. So going to the studio and then taking it in a green screen where I have to sit and teach you, I think this is better. Or if you have 5 lakh rupees, give it to me. I'll put it up tomorrow. No worries. Okay? Yes. Now don't do this. Yeah. Please switch to smart board from next class. Who do you think is going to provide the smart board? Huh? Who is going to provide the smart board? Chalo. Okay guys, moving on. So now all you have to do is, what is n value? N value from the question you can see that it is 2, isn't it? So 1.10 is equal to 0.0591 divided by 2. Log of k is going to be equal to 37. Yes? Yes, log of k is going to be equal to 37 only. This is simple, easy. So I think option B, 10 to the power 37. This is what you guys are telling me. Yes, k is equal to 1 into 10 to the power 37. Very good. Next question is, given 2H2O plus O2 plus 4H plus 4 electron E naught is equal to given. Calculate the electrode potential at pH 5. pH 5 guys. pH is equal to 5 is given to you. Okay? Alright, so first of all everyone, we all know that Nernst equation everyone is E is equal to E naught minus 0.0591 divided by N log of Q. Am I right? This is what is our Nernst equation. So that means that E is equal to, see, E naught value is given to you, so minus 1.23 minus 0.0591. What is N? N value is going to be 4 electron, as you can see in the question, right? So I can write here 4, okay? Then in the product side, it is 4H plus, so log H plus to the power 4 I can write, isn't it? I can write it like this. Very good, okay? Now, minus 1.23 minus 0.0591 divided by 4. For this particular place, let us use the property. So we can write it as 4 into minus log H plus. Can we write it like this? Yes, can we write it like this? We can. So from here, minus 1.23 plus 0.0591, 4 and 4 will get cancelled. Yes. Multiplied with, so minus log H plus becomes your pH, isn't it? This becomes your pH. pH value is also given to you, so minus 1.23 plus 0.0591 multiplied with pH is equal to 5, so multiplied with 5. Now tell me what is the answer, everybody. Now tell me what is the answer, guys. What is the answer? 5. What is the answer, everybody? Can you tell me quickly? Game over Tamil is also saying option A. Okay, option A it is then. Minus 0.93 volt. Very good, guys. Very good, very good, very good, very good. Chalo. Moving on, everybody. Now let us take a look at electrolysis. Everyone, are we ready for electrolysis, guys? Are we ready for electrolysis, everybody? Yo, guys, electrolysis ready? Hey Yashik, don't ask me these kind of questions now. Equilibrium, ionic equilibrium, chemical equilibrium, solubility, product, where we calculate pH and all. Have you forgotten everything? Guys, somebody please explain, no? Ashik is asking why minus log H plus is pH. What is log of H plus? Not minus log H plus, log H plus. What is log H plus, everybody? Please explain this to Ashik, someone. Oh, thank you so much. Thank you so much, Sham. Thank you so much. That's so sweet. That's so sweet, bacha. Okay, now guys, we are going to take a look at electrolysis, everyone. What is electrolysis, my dear bacha? Electrolysis when you have, when you are very young, okay? Yes? Very good, Tanishka. So, Ashik, do you see? pH, what is pH? pH is equal to minus log H plus. That's a formula that we have learned in the chapter that is called as chemical equilibrium, right? Yes, there are certain questions where we find the solubility product. There are certain questions where we try to figure out the pH and all of that. So yes, that is what it is. Okay? Alright? Yeah, Ashik, you have forgotten. I think no worries. We will anyway revise, right? We will do the backlog clearing and revision and all of this. So don't worry. Anyway, guys, coming to electrolysis. Electrolysis is what? Electrolysis is the process of chemical deposition of electrolyte by passing an electric current. In fact, not even that. The word electrolysis is made from two words. Electro means electricity, lysis means disintegration. That means breaking down. So when you pass electricity, what you do is you break it down. When you break it down, you get two different products. And one of them is attracted to the anode and the other one is attracted to the cathode, everybody. So do you remember in your class 8 you have studied about electrolysis of water? Yes, electrolysis of water. Do you remember, everyone? Do you guys remember this? Yes? Do you guys remember this? Electrolysis of water? Yeah. Yes, exactly. But in this case, one thing that happens here is cathode is negative, anode is positive. But anyway, don't worry about it. We will be talking about it. So in this case, in electrolysis, what happens, everybody, is electrolysis, obviously, it depends on certain things, right? First of all, read the statement. The statement is that it is a process of oxidation and reduction. But if there is anode, if there is cathode, if there is oxidation, if there is reduction, that means that it is a process of oxidation and reduction, right? Why is it happening? It's happening because of the current. And where is the current passing through? The current is passing through electrolytic solution, isn't it? The current is going through, the current is passing through electrolytic solution, and that electrolytic solution is broken down. When it is broken down, it gets deposited into different electrodes. The cell that we use here, that, my dear student, is an electrolytic cell. Okay? Alright, this is clear. Now, the product that we obtain during this electrolysis obviously depends on certain things. Of course, it depends on nature of the electrolyte. What kind of electrolyte are you taking? It depends on that. The concentration of electrolyte. How much of the electrolyte are you taking? The amount of electrolyte you are taking. Is it much more concentrated, or is it very dilute, right? The charge density flowing during the electrolysis, it depends on that, and the nature of the electrode as well. So when we talk about nature of electrode, guys, do you remember in the standard hydrogen electrode, what did we take? There was also platinum. So everybody, we all know that platinum is inactive. It's a noble metal, isn't it? So this particular metal here, platinum, if you take platinum, okay, if you take platinum, do you think the platinum will participate in the, in the reaction or what? It will not participate in the reaction at all. So that is called as your inactive electrode. Okay, platinum is not going to participate. Platinum, they conduct electrons into or out of the cell, but platinum is not going to participate. Hence, it is inactive electrode. But if you have an active electrode, that means the metal electrode itself takes part in the electrolysis, then we like to call that as an active electrode, everybody. And that is exactly what is written in your NCERT as well. Alright, everybody, the product of electrolysis. So what is the product of electrolysis? For example, if you take NaCl, everybody, there will be Na plus and Cl minus. the product that you are getting, that will also depend on certain things. Nature of material, what is the material that you are taking, what is the type of electrode you are taking, and the kinetics of the reaction. So right here, as you all see, nature of the electrolyte, I've just told you. Concentration of the electrolyte, yes, I've just told you. Charge density flow during the electrolyte, nature of electrodes used, and it also depends on kinetics. When we talk about kinetics, everybody, chemical kinetics, the whole chapter was based on one principle, and that is the chemical reaction feasible or not? Isn't it, everyone? Do we all know this? Yes. Is the chemical reaction feasible or not? That is something that is told by chemical kinetics. So sometimes what happens is we think that yeah, definitely this reaction looks like it is feasible. Here is an example I'm going to show you. Okay. But what happens is actually the reaction is not feasible. Actually, it's not seen to be feasible. Okay. Actually, it is not seen to be feasible. At that point of time, there is a problem that arises, which is called as over potential or over voltage problem. That also we will talk about it. So guys, everybody, are you all ready? Yes? Are you all ready, everyone? Shall we take a class? Shall we continue with the class, everyone? So imagine that you have molten NaCl, okay? You're going to use molten NaCl, and this time you are using inert electrodes. That means you are not using the electrodes that are going to participate in the electrolysis. So at the cathode, what is happening? Na plus is gaining electron. It is gaining one electron and it is forming Na, right? It is forming Na. Here, if you look at it, the E0 is given as minus 2.71 volt. At the cathode, what is happening, everybody? At the cathode, my dear student, as you all can see, there is 2Cl minus, okay, 2Cl minus. All right, what happens is it gains, 2Cl minus gains 2 electron and it forms Cl2, everybody. Here, E0 oxidation is happening because it is gaining electron, and here loss of electron is happening, isn't it? Yes, so, sorry. At cathode, what is happening here, everyone? Gain of electron. Yes, at cathode, gain of electron is happening. That means reduction is happening, and here oxidation is happening because this is losing the electron, right? Yes. So everybody, here you see that it is minus 1.36. Now, when you are going through the electrolysis of molten NaCl, it gives you sodium metal and it gives you chlorine gas, right? Yes. These two processes that you just saw, do you think that there is a natural tendency to occur? Because obviously we are probably trying to understand that, isn't it? Yes. Guys, everyone, can you please pay attention? What are you guys talking about? Yes, Santosh, what are you talking? So much you are talking and you're not trying to understand. Then later on you will tell me that, ma'am, kya bol rahe ho? Not understanding. Everybody, please look at this carefully. See what is happening. Normally what happens, guys, sodium gives away one electron, right? Sodium gives away one electron, but here see, Na plus is gaining one electron and forming Na. Reduction is gain of electron. Sodium is going through reduction, everybody. Can you see it? Yes. At anode, see what is happening. Cl minus. Yes, it is going through oxidation. It is losing 2 electron. Yes, everybody. So these two reactions, naturally there is no tendency for it to happen. Yes, but they are made to occur. How? Obviously, we supply some external energy to make this happen, isn't it? Guys, did you see, everyone? Please look at this reactions a little carefully, everybody. And can I get some chat? Yes or no? Are you guys even listening, or you are not listening at all? Should I end the class, everybody? Chalo, okay, don't answer. I will teach. I'll continue teaching and I will go. You want to learn, you can learn. Okay? Chalo. So here, if you see, everybody, what is happening is, what we do is we take concentrated NaCl. Concentrated NaCl solution, when we take, that means that it is called as a brine solution. Yes. Concentrated NaCl, aqueous concentrated NaCl, whenever you take, that is called as brine solution. So once again everybody, if you look at it, at cathode what is happening is sodium is gaining one electron, it is forming sodium solid, okay? Yes, and then what is happening is there is obviously aqueous. Aqueous means that there is water also, right? H2O is also there. So 2H2O plus 2 electron, it is forming H2 plus 2 OH minus. Do you see? Do you see everybody? Now if you look at it, so here E naught R for sodium is minus 2.71 volt and E naught R minus 0.83 volt for water. Okay, all right everybody. At water dissociation, see what is happening, okay? So the primary change here is 2H plus 2 electron forms your H, right? H2, hydrogen gas is forming, and 2H2O liquid is going through 2H plus 2OH minus, right? That is something that everybody knows, isn't it? This is something that everyone knows, right? Yes. How does water dissociate? H2O will form H plus OH minus ions. Am I right everyone? That is something that we all know. This, correct? Yes. But what is the primary change that is happening? The primary change that is happening is this 2H plus ion that has been formed after dissociation of water. This H plus ion, now it gathers 2 electron and it forms hydrogen gas. So altogether the reaction becomes this. Okay, altogether the reaction becomes this. Now check it out everybody. Now what is happening is at anode the reaction follows something like this. Yes. Cl minus gives away 2 electron. Cl minus gives away 2 electron to form chlorine 2 gas. And once again there is water everybody. So water will become O2 plus 4H plus 4 electron. Please check out the E naught of oxidation, minus 1.36 volt and minus 1.23 volt. Now because the oxidation potential of water is so high here, ideally H2O gas should discharge instead of chlorine. Yes, it should be discharged. H2O should be discharged. Now you guys must not be getting it, right? You guys must be thinking that, ma'am, what are you teaching? We cannot understand. So let me show you something here everybody. I think I have written it before Kohlrausch's law, somewhere I had written it. Let me show you. Yes, so this is called as preferential discharge theory everybody. Before we understand that why is H2O getting discharged and why is Cl2 getting discharged, or what do you even mean by discharge, let us understand preferential discharge theory. So people, all these while we were understanding that Zn plus there was ZnSO4. Yes, Zn was doing what? It was giving away 2 electron and it was forming Zn2 plus. What was copper doing? Copper sulfate was already present and there was copper that was getting deposited in the copper rod, right? There was more, copper rod was becoming thicker if you remember. Yes everybody. But what if instead of having just one ions that are supposed to get discharged, what if there are more than one ion? What if there is more than one type of ion? That means that both of them will get attracted by the electrode, right? Both of them will have a competition between them that, hey, I want to get deposited, hey, I want to get deposited, hey, I want to get deposited, I want to get deposited. There will be a fight between them. At this point, there is a preference. That means who will be getting discharged, who will be getting deposited, that is decided by someone. For cations, the discharge potential is going to be standard oxidation potential. So if there is more standard oxidation potential, higher will be the discharge. Okay. For anions, the discharge potential will be related to standard reduction potential. But this statement you can remember, not the statement, this series you can remember everybody. SO4 2 minus has the least discharge. Okay, if there is SO4 2 minus and if there is Br minus, then bromine will run and bromine will get discharged. Now everybody look at it. There is OH minus and there is Cl minus. Who is going to get deposited? See, Cl has a higher tendency. Cl will go and get discharged. So guys, everybody, are we understanding the preferential discharge theory, everyone? Guys, are you all here? Please quickly write down EPBT, la, something please. And now please read this statement that I have written and try and tell me that did you understand preferential discharge theory. If you did, then we will go to the Then we will go and understand the electrolysis product, everybody. Please quickly go ahead and let me know. Till then, I'm going to drink some water. Then we're going to solve some more problems, everybody. Quickly, guys, go ahead. Let me know in the chat box. Yes, so those students who are studying, yes, are we clear? Do we understand EPBT? Yes. Do we understand this preferential discharge theory? Great. If we have understood this now we will go back and we will try to understand this, guys. Where is it? Yes. So now if you look at it, everybody, I think now you will understand. So here what is happening? Oxidation potential of water is high. H2O should get discharged, but instead chlorine is getting discharged. Here now we have two reasons. First of all, I have just told you Cl minus has a higher preferential discharge theory. Cr minus has a higher preferential discharge than OH minus. And the second problem, remember, over voltage. Second problem is over voltage. We are externally applying the energy, isn't it? Yes. We are externally applying the energy. So now do you understand that instead of hydrogen and so this slide, when we were talking about this slide, we saw that yes, it was sodium. Yes, it was sodium that was E naught for sodium was very less. So it was going and getting accumulated. But E naught for Cl minus was higher, yet because of two reasons that got deposited and not hydrogen, everybody. Am I clear, guys? Am I clear, guys, everybody? Yes? And now let us talk about the over voltage, or somewhere you must have also heard it as over potential. Both of them are correct. Both of them are fine. You can use over voltage or you can use over potential. Both of them are fine. So what happens is, in the electrolysis of concentration, when we have taken sodium chloride as an exception, what occurs here is there is a phenomena that we get to see, which is called as over voltage. Here what happens is, when the liberation of gas, that means production of gas, is happening, it is observed that the applied voltage is more than the predicted one. The difference in the practical and theoretical value, that is called as over voltage, everybody. Clear? Hey, what did I say, everyone? I have just told you. So here what we see is the applied voltage and the predicted voltage, they are different, and that difference is your over voltage. This over voltage, we require it because the magnitude of the current that passes through our electrolytic cell is often limited by the rate of electron transfer at the electrode solution interface, and over voltage is actually generally very small, which and it can be as large as 1 volt also. Yes, guys, I know I have read the statement, but please go through. Did you understand what is over voltage, everybody? Did you understand, or is there a need to explain this again, everyone? Is this clear? Now, here see what happens is, So there are 4 different cases, everybody. Case 1, let's say that E value for Na plus to Na, okay, when sodium plus is getting converted to sodium solid, it is minus 2.71 volt, right? Here, over voltage for this reaction is 0.1 volt to 0.3 volt, okay? But the voltage required for discharge is minus 2.72 volt or 2.74 volt. Why so, everybody? Check it out, guys. See, case 1, E is equal to Na plus 2, Na is minus 2.71 volt. Over voltage is 0.1 volt to 0.3 volt. That means that the voltage required for discharge will be, what are we doing? We're just adding it, isn't it? We're just adding it. Minus 2.71 minus 0.1 or 0.3, if we do, we will get this value. Am I right, everybody? Am I right, everyone? Why over voltage occur? Moe. No. Haven't you seen? It's written here, right? It's an exception. In the electrolysis of concentration of NaCl solution, an exception occurs due to the phenomenon called overvoltage. Here we see this exception as overvoltage. Not always, but you can see it, okay? You can see it in many cases, okay? Alright. How overvoltage occurs? That also I explained it to you, no? See, when gases are getting produced, we observe that the applied voltage, that means the voltage that we are applying, and the voltage that we predicted, there is a difference. That means the practical and the theoretical values are different. Like, abnormal molar mass you had, redox family. Do you remember? Van 't Hoff factor, abnormal molar mass divided by calculated molar mass, normal molar mass, calculated divided by theoretical. Do you remember, everybody? Yes, so sort of like that. That is the reason of overvoltage. Tanishka, I hope that I have explained your doubt as well. Have I? Remember that Van 't Hoff factor I is equal to what? Theoretical, calculated, abnormal, normal, sort of like that. That is what it is. Obviously, those differences will come, right? Yeah, exactly. Now see, look at case 2. Here also see what is happening. H2O, water is getting converted to hydrogen gas. So, it is E value is minus 0.83, okay. Now the over voltage here is 1 volt, guys. Over voltage here is 1 volt. At this point, minus 0.83 minus 1 volt, when you do, you will get 1.83 volt. So now everybody, you tell me, what are the products of electrolysis of NaCl? Molten NaCl, what are the products? Write it down in the chat box, because very soon you will be getting this question. I'll be doing this. So case 1, case 2, case 3, case 4 is absolutely similar. All you are doing is you are just subtracting it. Basically, when minus and minus you are subtracting, you are getting an added up value, and you are seeing that the voltage required for discharge is higher than the E value, okay, higher than the E value. All right, everybody. So now tell me, what is the product of electrolysis, guys? At cathode you have something, at anode you have something. Overall is also written here. Yes, guys, come on. What do you see? You check it out right here, everybody. So the product of electrolysis of sodium chloride, and not just sodium chloride, molten sodium chloride, everybody. The product of molten sodium molten sodium chloride, what will happen is you will get, because there is also water in it, you will be getting sodium hydroxide, there will be chlorine gas, and there will be hydrogen, not sodium. Yes, guys, check it out. So resulting solution here will be basic because of sodium hydroxide. Yes, getting my point, everybody? Did we all notice what happened here? Everybody? Yes or no, guys? Yeah, I will explain conductance topic. Obviously, I will explain. NaCl, H2, Cl2. Very good. Okay. All right, everybody. Yes. Very good, everybody. Yes. Why water in molten? Let's go to the very beginning. People, when you ask these sort of question, no, I really do not know what to say at that point of time. Read here. What are we doing? Read the first thing. Yes, God, what is the doubt? Don't come and tell me that this channel is best or that channel is best. Great. There are many channels that are best. You like something, you can definitely study. But don't go ahead and, put that in the class and disturb the class. Tell me what is your doubt. Please tell me what is your doubt. I have asked you. Look at this. Look at this. How many times do I have to ask you what is your doubt? Constantly you're spamming from that time. And to all the students, everybody, we were talking about concentrated NaCl aqueous. Aqueous is written. Aqueous is written, everybody. That means that water will be here, right? Yes. Oh, did I say more? Sorry. Why was I saying molten? I do not know. Sorry. NaCl aqueous. NaCl aqueous. We were talking about product of electrolysis. Extremely sorry that I scolded you. Yes, guys. Chalo. Moving on from here. Chalo. Moving on from here. Yeah. Okay. This is over. Now, electrolysis of aqueous NaCl using platinum electrodes. Okay. Alright, let us use platinum electrode and we are taking dilute NaCl aqueous solution, everybody. Right now, yes. Is that so, Tanishka? Maybe. Possible. Yeah, because I am getting your chats a little later. Chalo, no problem. It's okay. Guys, moving on, everybody. Moving on. So just now we have spoken about the product of electrolysis, but we had spoken about what we did speak about concentrated NaCl. Now if we take dilute NaCl, everyone, then what will happen? At the cathode, same reaction as the concentrated, right? Once again, the E naught is minus 2.71 volt that we can see. At cathode, you will also see, because it is dilute NaCl and it still is aqueous solution. So here you have 2H2O plus 2 electron, that becomes hydrogen gas and it becomes 2OH minus, which is aqueous, right? Here again, the E naught R value you can see is minus 0.83 volt, guys. Okay? You know what? Let me move away my face so that you all can understand this better. Guys, please take a look at it. Okay? At anode, what is happening is Cl minus, which is in aqueous form, is going to get converted to Cl2, that is chlorine gaseous. That means gas is getting liberated, everyone. Gas is getting liberated and 2 electrons are here, as you can see. This time the E naught value is minus 1.36 volt. And obviously, because water is present, so once again we will see that 2H2O will become O2 gaseous plus 4H plus, yes, plus 2 electron, everyone. And here we see that it is minus 1.23 volt. So the overall reaction from these 1, 2, 3, 4 reaction, if we calculate it, then we get here, see 2H2O, here 2H2O, right? Yes, everybody. Then you also have here 2Cl minus, okay? Here you have 2H2C, 1H2 is here, and here also you have H plus, so you have 2H2. Then you have O2, yes, then you have 4H plus, and you have here 4OH minus. This how did we do? Obviously, we have multiplied by different whole numbers, right? We have multiplied these equations with different whole numbers, and then we get this overall reaction. Or we can also write it, we can simplify this reaction, and we can write it as 2H2O gets 2H2 plus O2. That means 2H2O gets converted to 2H2 plus O2, everybody. Yes. So at cathode, we see that still water will be discharged at cathode. Yes. At cathode, still water will be discharged. At anode, water will be discharged because of less concentration of Cl minus. This time, there will be less concentration of Cl minus, unlike the previous time where we saw that Cl minus will have more preference to get discharged than OH minus. But right now, remember in the beginning we have told you that electrolysis of product, it depends on what is the concentration of electrolyte. So if we are taking dilute NaCl, then what will happen? Hydrogen will get discharged. Yes, everybody? Are we understanding? Yes, are we understanding? Okay. Now you are not solving. Mark khayega tu. Yes, do you understand virtual punch, virtual slap? You will get that. Because do you notice that I am not your personal teacher? I'm teaching on YouTube for a major vast class. So I will not be able to solve a question that you are giving me. I will give you homework, okay? I will solve it. I will give you homework, you will solve it. I am not your personal teacher who is going to solve a question that you have gotten in homework. And don't try to even test me. Don't think that you will give me a question and try to test my knowledge. Don't do that. Sit in the class, listen to the class like how everybody else is. Don't spam like this, okay? Be a good student. Use the formula and solve it on your own, okay? Don't do this. I'm not your personal teacher who's going to solve your homework. No. Chalo. So everybody here, once again, I have made a cheat code, okay, or a cheat sheet, as you would like to say. Then here is a cheat sheet for you all, everybody. And whenever you have a electrolyte, you can have a look at it. What is the product of electrolysis of some electrolyte? Now, guys, I understand that you still have a question that, ma'am, how do we figure out which electrolyte will have what product? Would it be okay if I make a short video on a trick? Because I do have a trick. I might be able to make a, I'll be able to make a trick video of a 5-10 minutes maximum. 5-10 minutes I'll make a video that you will be able to watch it before your exam. Yes? Before your exam, will you all be able to watch that, guys? Because I think I'm going to do that. I'll make a trick and you will be able to find out that what is the product for each and every electrolyte. Yeah, I think that will be really helpful. So I'll do that, no worries. But now see, if you have aqueous NaCl and if you have electrode that is platinum or graphite, then the product that you will obtain at anode will be Cl and the product that you will be obtaining at cathode will be hydrogen. All right, everybody. Yes, similarly you have it for all. I would suggest that you can print this out or you can just copy it in your notebook, tear the page and stick it in front of you so that you go through this, because these type of questions may come in JEE. Product of electrolysis is a predictable question in JEE, everybody. So go through this, okay? Go through this. This whole cheat sheet is right in front of you. I don't really have to teach you, but you can go through this, okay? All right. Chalo guys, let us solve some more question, okay? During the electrolysis of fused NaCl, which reaction occurs at anode? Which reaction occurs at anode, everybody? I think all of you will be able to tell me that chloride ions are oxidized, right? Isn't it option A? Chloride ions are oxidized, right, everybody? Yes, that is absolutely correct. Moving on to the next question. What are the products of electrolysis of aqueous NaCl? Aqueous NaCl, what are the products of electrolysis, everybody? The product of electrolysis is Cl2 and H2, isn't it? Cl2 and H2, right? Cl2 and H2, everybody. Moving on, sodium is made by the electrolysis of a molten mixture of about 40% NaCl and 60% CaCl2. Because, why? Why? No, because what happens here is this mixture that you take, right? If you take 40% NaCl and 60% CaCl2, then what happens is this mixture, it has a lower melting point than NaCl, okay? It has a lower melting point than NaCl. That is why you take it. Now, guys, we have come across the very important, this electrolysis. So, electrolysis has happened, right? But how do we quantify? How do we quantify electrolysis? Again, chemistry hai, again, science hai. So that means quantification is very important for us. Hence, we come across Faraday's first law. Now, Faraday said that the mass produced by any substance during electrolysis, it is proportional to the amount of current that is passed through the electrolysis, or amount of charge that is passed through the electrolysis, which is given to you as W is equal to ZQ. What is Z? Z here is the ECE, or electrochemical equivalent of the substance, we like to say, okay? What is ECE? Electrochemical equivalent. Now, W can also be written as Z multiplied with I multiplied with T, because Q is equal to IT, isn't it? Q is equal to IT, hence we write it as W is equal to Z multiplied with IT. What is unit of Z? You can clearly see that there is mass involved somewhere, there is charge involved somewhere, right? So it will be mass divided by coulomb, that is kg divided by C, or it is gram divided by coulomb. Gram per coulomb, kg per coulomb, okay? What is Z? Z is the mass deposited when 1 coulomb of charge is passed into the solution. And what is the charge on 1 mole of electron? That, my dear student, is 96,500 coulomb, or it is considered as 1 Faraday. Okay. Then there is a concept of equivalent mass as well. What is this concept of equivalent mass, everybody? It is mass of any substance that is produced when, my goodness, I dropped a lot of things. Sorry. I dropped a lot of things, basically. Everything in my room, I have just dropped it off. Chalo, anyway, no problem. I think let's continue with the class. We are almost about to be done. I could have dropped my laptop and everything, guys, but somehow I escaped. I thought I will just lean on the wall a little bit. I was trying to pull it and I dropped everything. Thank God that the light and everything did not get dropped. But anyway, chalo, moving on. So what is equivalent mass, everybody? Equivalent mass is basically the mass of any substance, okay? Mass of any substance which is produced when we have 1 mole of electron, yes, and that is passed through the solution during the electrolysis, okay? During the electrolysis, when 1 mole of electron is passed through the solution, and what is the mass of any substance produced? That is called as your equivalent mass. Clear here, guys? Any doubt here? Okay. Then there is the derivation which you all know. Now let us calculate, everybody. Chalo, let us solve some more questions, because questions are the most important part of your JEE preparation. So what current is to be passed for 0.25 second for deposition of certain weight of metal which is equal to its electrochemical equivalent? See, I just told you electrochemical equivalent. What is it, everybody? So guys, once again, let me try and solve it for you. Oh my God, what did I do? Of course, Piyush, of course. Yeah. And your results, your JEE result will kill everybody else. And your dreams will also be killed. Keep doing that only. 4 ampere, very good KKB, very good. But let me try and solve it for you once again. So we have noticed that W is equal to, capital E, IT divided by F, right? We can write this. But we also know that W is equal to Z. Z is what? Z is the electrochemical equivalent, which is what is written here, right? Yes, which is what is written here. So that means that we can also write it as Z is equal to EIT divided by F here. Yes. And we know that Z multiplied with F. I don't know if you can see it. I think you cannot. You are not able to see it. Sorry, guys. So Z multiplied with F is equal to your E. Am I right? Absolutely. So that means that E is equal to EIT. I can write from here. E and E will get cancelled. That means that IT is equal to 1. Can I write? Absolutely. That means that I is equal to 1 divided by T, and it can be written as 1 divided by 0.25. That is what is given. So 1 divided by 0.25 is equal to 4 ampere. Absolutely. Option A is the correct answer. Very, very, very good. Okay. Very good. KKB, you are absolutely right, bacha. 4 ampere is the correct answer. Chalo, next question, everyone. The time required to coat a metal, okay? The time required to coat a metal surface of 80 centimeters square with 5 into 10 to the power minus 3 centimeter thick layer of silver. Density is given to you by passing a current 3 ampere through silver nitrate solution. My goodness, this is so easy. I believe that you will all be able to do it. So what do we have to do? We just have to take that mass of silver, okay? Mass of silver in coated layer. Mass of silver, coated layer. What is it going to be? Mass is equal to volume into density. Am I right, everybody? Yes. Volume into density. So how do we calculate volume? Volume, see, 80 centimeter square multiplied with 5 into 10 to the power minus 3. Yes. So it will be 80 multiplied with 5 into 10 to the power minus 3. And your density is also given to you as 1.05, isn't it? Calculate this, everybody. Tell me what is the answer. Okay. Then what do you have to do? Here we can see that W is equal to IT multiplied with E divided by Faraday, that is 96500, right, everybody? So that means that T is equal to W is equal to, did I write W is equal to? My God. W multiplied with whatever W you are getting here, that you have to tell me, okay? T is equal to 9650, W multiplied with 9650 divided by I multiplied with E. So that means here, whatever you are getting here, let's call this as X. So X multiplied with 96500 divided by I is 3 amperes. So 3 multiplied with E. What is silver's mass? 108, isn't it? So 108. Now calculate, guys, and tell me what is the time, everybody. Tell me what is the time, guys. Did you get it? 0.42. X is equal to 0.42. So 0.42 multiplied with 96,500 divided by 3 into 108. Do that and let me know the answer. Let me know the answer. Let me know the answer, guys. Thank you so much, Tanishka. Thank you so much. Yes. What is the answer, guys? How much is the time that you will be required? How much time will you be requiring? Come on, come on. Chalo, I think you can solve it. You solve it later. Okay, option number B is the correct answer. Option B is correct answer. Now we come across Faraday's second law, everybody, and when same quantity of electricity is passed through a solution of different electrolytes. Let's say that you have KCl as an electrolyte, you have CuSO4 as an electrolyte, or let's say that you have different electrolytes. But when you have passed through the same quantity of electricity, and if they are connected in series, then the equivalent of substances deposited will be also same. So from here we get that for at any electrode for material deposited, if they are connected in series combination, everyone, then you get this. Then you get this relation basically. What is the relation? Relation is W1 divided by E1 is equal to W2 divided by E2 is equal to W3 divided by E3, everyone. Yes, this is your Faraday's second law. So now, let us do another question, shall we? Let us do another question, everybody. Chalo. Chalo, guys, let us do this. Okay, here. In an electrolysis experiment, a current was passed 5 hours, okay, through 2 cells connected in series. Alright. The first cell contains a solution of gold salt and the second cell contains copper sulfate solution. 9.85 gram of gold was deposited in the first cell. If the oxidation number of gold is +3, find the amount of copper deposited on the cathode in the second cell. Also calculate the magnitude of the current in ampere. Hi, cute Bandar. Oh my God, you're so cute. I'll give that to you. I'll give that to you, Tanishka. Don't worry about it. Okay, we will do that also. Okay, don't worry. We will do that also. But pehle, let's try to solve this question, shall we? Let's try to solve this question, everybody. Come on. See what is given to you. Chalo. Let me try and solve it for you. Okay, so it is saying that in an electrolysis experiment, a current was passed for 5 hours. Okay, 5 hours, 5 ghanta. There were 2 cells that were connected in series. The first cell had some gold salt, okay, and the second cell had some copper sulfate solution, okay. 9.85 gram of gold was deposited in the first cell. All right. And if the oxidation number of gold is +3, that is also written, you have to find the copper deposited on the cathode in the second cell. So guys, let us do this. Okay. Now what do we know? We know that if the mass, okay. Wow, again the pen went off, guys. Give me a moment. Till then you read the equation. Tanishka, actually in this question only you will get that relation. Right here now only you will get this thing. You will get the equation, I think. Okay. All right, guys. So what do we have? We have mass of gold, right? So gold, I can write it as Au deposited. So mass of Au deposited divided by, I can write mass of copper deposited, isn't it? Mass of Cu deposited. Am I right, guys? I can start writing like this. And if that is the case, that means here EQ mass, equivalent mass of gold divided by, I should also get equivalent mass of copper. I should also get equivalent mass of copper. Am I right, everyone? Yes? Right, everybody? Very good. Now what do we know is, we know that equivalent mass, okay? Equivalent mass of Au. How do you calculate equivalent mass of Au? How do we calculate? Guys, somebody can you tell me what is the mass of gold? What is the mass of gold, guys? What is the mass of gold, everybody? Come on, quick, 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 quick. Chalo, I will only write it. This is 197 divided by 3. Okay. Now, if we want to calculate equivalent mass of Cu, equivalent mass of Cu is going to be 63.5 divided by 2. Copper sulfate, isn't it? CuSO4, so that means Cu2 plus. So that is Cu divided by 2. Okay. Now, we want to calculate mass of copper deposited, okay? If we want to calculate mass of copper deposited, what do we have to do? 9.85 gram of gold was deposited, right? That's written. So, 9.85 multiplied with 63.5 divided by 2, can I do? Yes, I can. Multiplied with this reciprocal I have to take. Yes, I'll have to take the reciprocal. So 3 divided by 197 can I take? Calculate this and tell me what do you get the answer. Yes, I will move on. Calculate. Calculation part I'm leaving, okay? Very good. Thank you, Tanishka and Cute Bandar. Very good. Thank you so much. Okay. Now, guys, let Z be the ECE, okay? Z be the ECE. ECE, you know, electrochemical equivalent of copper, okay? Let Z be the electrochemical equivalent of copper, everybody. Okay, if that happens, then how can I write it? I can write it as E is equal to Z multiplied with Faraday's constant, that means 96500. Can I do this? Or what I can do is Z is equal to E divided by 96500. That also I can do. Yes. Which is equal to, what is E, guys? E will be 63.5 divided by 2 multiplied with 96500. Can I not do this? I can absolutely do this. At this point, what do I want to do? At this point, I want to apply an equation. Look at this, Tanishka. Look at this. What do we apply? We will apply W is equal to Z multiplied with I multiplied with T. So yes, do you have this equation? Now are you able to understand? Z is equal to E divided by Faraday's constant and W is equal to Z multiplied with I multiplied with T. So Tanishka, are you getting your answer? Did you get your equation? I hope you get it. Yes, I hope you get it. Yes, from here only you can figure it out, I think. I don't have to give it. Now what is given in the question is that T is equal to 5R, right? T is equal to 5R, correct? So that means what I can do is 5 multiplied with 3600 second, because minute to second, second to minute, minute to hour. Yes. Yes, thank you so much, Tanishka. Thank you. We will write that again. 4.7, isn't it? Okay. Now we will need it. So W is your mass of copper deposited. So that means 4.7 is what Tanishka is telling me. I'm writing that 4.7 multiplied with 63.5 divided by 2 into 96500 multiplied with I multiplied with 5 into 3600. Calculate this and tell me what is I is equal to, everybody. What is I equal to? Calculate and tell me. You must get it in ampere. Must get it in ampere. Okay? Alright. So guys, I think we are done. Okay. Rest of the questions that are related to Faraday, I am going to give this you as homework because we have lots and lots of questions, everybody. Preferential discharge theory, we are done with it. I have explained this to you, and now finally we come across conductance, everybody. This is not a very difficult topic actually, to be very honest. Conductance is what, guys? We all know, we have learnt about it in the very beginning, that there is metallic conductors, there is electrolytic conductors. So when we come into this chapter, we are mostly talking about electrolytic conductors. Yes, we are talking about electrolytic conductors, hence we also come across conductance. So any solution which has an electrolyte, which contains cations and ions, which can flow through the solution between the electrodes, yes, that will have some conductance. And this flow of ions is not a free flow, because there will obviously be some resistance. And how do you write resistance? R is your resistance. R is your resistance is equal to rho multiplied with L divided by A. What is rho? Rho is the resistivity or specific resistance. Okay, rho is the resistivity, or it is specific resistance. Okay, what is L? L is going to be the length of the resistor. Once again, this is a very physics related formula. So I know that you all know, in physics also you have learnt about current, in physics also you have learnt about electromagnetic induction and all of these. So this should be very simple, right? Yes, and A is area of cross section of resistor. Okay. Bro, one last warning to you, okay? You do this one more time, I'll completely block you from the channel. Completely block you from the channel. Don't do this. Don't do this. Try and understand. A, I am much more older than you. Respect. B, I'm taking a class. There are other students who are sitting in it. C, you are coming into the class and you are disturbing by just asking me some questions. Even if you just sit in the class and if you listen to it, you will be able to solve the problems. So last warning for you. Now you can go ahead and tell me anything. One more thing you tell me, you will be blocked from the channel completely. Second time, nobody, none of the other teachers will also be able to see your chat. So you decide what you want to do. Okay? Don't do this. Yes, and here, obviously, because we are talking about resistance, what is resistance unit, guys? We always know that it is ohm, isn't it? It is ohm, O-H-M, and this is the symbol of ohm, everybody. Cool? All right. Yes. Now, from this equation that we have just done here, that resistance is equal to rho multiplied with L by A. From here, we can also we can also get the relation of conductance. Okay, and what is conductance denoted by? Conductance is denoted by capital G. So capital G is equal to 1 divided by R. That means reciprocal of resistance, obviously, because conductance that means that something is able to conduct, and resistance means something that is not trying to conduct. So it is the opposite, isn't it? So that means that from resistance we can also calculate conductance. 1 divided by R, that means 1 divided by resistance is going to give you conductance. Okay? If that is the case, that means that this formula can be modified and written as 1 divided by rho multiplied with area of cross section divided by length. Is that not, everyone? Yes. And now the weird or the funniest part of it is that the conductance, the unit of conductance is also written as ulta of this, which is mho, M-H-O. Okay, you can write it as mho. You can show it as omega to the power -1, or we can say that it is Siemens. Okay, S-I-E-M-E-N-S, Siemens. Cool, everybody? Yes, who has asked me that, ma'am, are you going to teach this thing? Ma'am, are you going to teach us the conductance part? Yes, bacha. See, I'm taking care of the conductance part also. Then what do? We, just like we had specific resistivity, which was rho, we also have specific conductivity, which is your kappa, everybody. Okay? All right, everybody. Cool, guys. Then what do? From here, we can also derive that G is equal to 1 divided by resistivity is equal to 1 divided by rho multiplied with A by L that we have just seen, isn't it? And kappa, that means, is 1 divided by rho, basically 1 divided by resistivity. Yes, 1 divided by resistivity, everybody. Okay? Alright, guys. Yes, everyone. Cool hai? Okay. Now, everyone, see, L by A, okay, L by A, if you see the length and the area of the cross section, if you take a cell, okay, then do you think that is going to be different? Yes, for that one single cell, will you be able to change the length and the area of the cross section again and again? No. So that means for a single cell, the length divided by area of cross section, it is going to be constant, which is why we are writing it as cell constant. ठीक है बच्चों, everybody, did we understand, everyone? See here, this is what it is. Again, that is there in your NCERT. I'll tell you the page number also. Page number is probably 73, Conductance of Electrolytic Solution, Measurement of the Conductivity of Ionic Solution. See this particular picture, everybody. Right here, okay? So from here to here, you will have a length. From here to here, you will have a length. And there will be area of cross section. This you will not be able to change. And that, my dear student, is your cell constant. Clear hai, everybody? Yes? Clear hai, guys? Clear hai? Okay. Now, let us talk a little bit. Array, where did it go? Now we're going to talk about a little bit about conductivity cell. Okay, so this is basically the diagram of the conductivity cell. Okay, here the blue color, shaded part that you see, these are your metal plates. Okay, this is the area of this plate, everybody. Right here, this will be the area of the plate. Yes, and here this red part that you see, that is your non-conducting plates. So in a conductivity cell, you have a metal plate, you have metal plates as well as you have non-conducting plates. Okay? And once again, everybody, just like how I told you, it is A divided by L, that means area of cross section divided by length. That will be same for the conductivity cell, right? And the kappa here will change depending on the nature of electrolyte. Whatever electrolyte you take here, my dear students, same thing. See, this electrolyte that you will take, right? Here, whatever electrolyte you take here, this blue color part, whatever you take here, depending on that, your kappa will change, okay? Your kappa will change. Yes? Yes, Tanishka, you are right. Yes, Tanishka, you are right. Thank you, Mani. Thank you so much. Yes. Now, for conductivity cell, the amount of current will obviously depend on the nature of electrolyte that I just told you. Higher is the value of kappa, that means more is its conductance. Why? Because more is its, no. Kappa is conductance. Sorry, rho I was considering. So, yes, if you have more value of kappa, then obviously conductance will be more. L divided by A is going to be constant because it is cell constant. And here, A is equal to 1 centimeter, L is equal to 1 centimeter, A is equal to 1 centimeter square. Yes, and the volume of the electrolyte, we have taken it as 1 centimeter cube. Okay. So, from kappa formula, which we know is G multiplied with L divided by A, if you substitute all these value of 1 centimeter cube, 1 centimeter square and 1 centimeter, you will get that kappa is equal to G. That means kappa is the conductance of 1 centimeter cube of electrolyte solution. Okay. Obviously, now when we talk about types of conductance, we have molar conductance and we have equivalent conductance. God was asking a question related to molar conductivity, isn't it? Calculate its molar conductivity. If the conductivity of 0.20 molar solution of KCl at temperature is this, calculate its molar conductivity, which is something that we will probably be doing in the next upcoming 10-15 minutes, everybody. Okay, so wait up, I'll tell you. Molar conductance is lambda m, conductance of 1 mole of electrolytic solution, and equivalent conductance is conductance of 1 equivalent of electrolyte solution. Alright guys, okay? Yes. Now for a solution, if the molarity is m, once again mole concept comes into picture, everybody. M moles means 1000 centimeter cube, and 1 mole means 1000 divided by m centimeter cube. So conductance of 1 centimeter cube of solution is equal to K, and here conductance of 1000 divided by m centimeter cube of solution will be nothing, 1000 multiplied with kappa divided by molarity, isn't it? Yes. So unit will become S centimeter square divided by mole. You can just put the values, you can just put the units here, and from here you can calculate it, isn't it? Yes guys. Hi Harihara, thank you so much bacha for coming up here again. Now how do you calculate molar conductance? Molar conductance you can calculate it with this formula, that is lambda m is equal to 1000 multiplied with kappa divided by m. And what is the unit? I've just told you, it is Simon centimeter square divided by mole. Yes, if you want to calculate equivalent conductance, then this is the formula, and there is a relationship between the equivalent conductance and molar conductance, and as you can see that lambda eq divided by lambda m is equal to molarity divided by normality is equal to 1 divided by z. That means this is the relation, everyone. Okay, this is the relation. And guys, once again I have given you a cheat sheet here that will tell you about conductance, specific conductance, molar conductance, equivalent conductance. Yes, all of their definitions are here, their change with concentration is mentioned, and their symbolic unit is also here, everybody. Okay, all of these are noted it down. So guys, shall we do some more questions, or should I just give it to you, everybody? Shall I leave this for you? Very good question. Why is alternating current used for measuring resistance of an electrolytic solution? Mani, use a little bit of common sense and you tell me that what will happen if we use a DC, a cell. You tell me. What will happen if we use a DC? Electrolytic solution, that means there are definitely, you are providing some electrical energy to make a chemical energy happen. So if you use a DC, that means the cell also has a chemical, the cell also has chemical, right? Yes. So what will happen? And Tanishka has already answered, by the way. Yes, Tanishka has also already answered, because in DC, the concentration will change and we need to find the resistance at a particular concentration. Exactly. So what will happen if you use a cell or a battery? Now you get the answer, right? You get the answer. Guys, shall we solve more questions or shall I give you this homework? Chalo, one I'll solve you. Let me solve you this. Chalo, let me try and solve this. After this, I think we are just coming to, what do we have? Then we just have Kohlrausch's law and then we are done, I think. We are done with Kohlrausch's law and then we'll be done, right? We're coming to the end of it. So 10 minutes, last 10 minutes, everybody, 3.5 hours of session. We will all be done, everybody. Okay? So what is it that is given to you? I have to use this also. Okay. What is given to you is length is given, 2 platinum electrodes, 2.1 centimeter. So L is equal to 2.1 centimeter. Hai na bachos? Yes, right. Now A is a 4.2 square centimeter, right? So 4.2 square centimeter. Am I right, everybody? Yes, very good. Okay, now resistance is also given to you, that is 50 ohm. Very good, everybody. Yes, all right. Okay. Now what do we do? Calculate the equivalent conductivity of the solution. Calculate the equivalent conductivity. Before that, we will have to calculate specific conductance. Specific conductance we will have to calculate, isn't it? So specific conductance is kappa is equal to L divided by A multiplied with 1 divided by R, right? So that means that K is equal to 2.1 divided by 4.2 multiplied with 1 divided by 50. Yes, calculate how much ohms it will be. 2.1 divided by 4.2. That means that this is 2.1, 4.2. 1 divided by 50. I think it should be 2 and to 50, 100. So 0.01 ohm to the power minus 1 centimeter to the power minus 1. Isn't it? Yes, very good. Now, equivalent conductivity, right? Equivalent conductivity, everybody, if we calculate, we will get it as kappa multiplied with V. Yes, what is the V here? V is the volume containing 1 gram equivalent. Okay, volume containing 1 gram equivalent. That means it is 1000 milliliter. It is 1000 milliliter. Yes, right? So the equivalent conductivity will be kappa. We have just calculated 0.01 multiplied with 1000 milliliter. If we do, what do you get? 0.01 multiplied with 1000, it will be equal to 10. Yes. So 10 ohm to the power minus 1 centimeter to the power square, right? And EQ to the power minus 1. Am I right, guys? This is what it is going to be. Yes? Is this what it is, everybody? Blacks badminton. No, bacha. This is not class 11. This is 12th, bacha. This is 12th. Okay? This is 12th. Okay? 10. Very good. All right, done. So similarly, there is another question. I will leave this for you. I think you can do this. Okay? And last but not the least, guys, we have come to Kohlrausch's law. What is Kohlrausch's law, everyone? Who can remember? Kohlrausch's law is basically what it tells us is that when you have diluted a solution a little too much, then what happens? And when you have not diluted a solution little too much, then what happens? Okay? All right, everybody? Yes. Acha. So, who was that who was asking molar conductivity? Yes, molar conductivity. What is the value of molar? What is the formula of molar conductivity? What is the formula of molar conductivity? Molar conductivity is lambda m is equal to conductivity divided by C, isn't it? Yes, conductivity divided by C. That's it. Yeah, that's it. I think you can do this. And you had already given all the values also. So I believe that you will be able to do it. Okay. Anyway, so now we want to understand the molar conductivity variation. So what happens is conductivity per unit molar solution. Okay. So concentration, right? Concentration basically means that there are, let's say that if I take, if I want to take this much area, in this much area, how many particles are there? If the particles are more, that means it will be concentrated. And if this much area, if the number of particles are less, that means it will be diluted. So if I dilute it more, guys, if I dilute it more, 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 then what will happen? Are you going to increase the number of particles? Not at all. Right? Yes, everybody. So when you are diluting, that means you are decreasing the concentration, you are increasing the volume. But kappa, your conductivity, that decreases because like I just said, that yes, what is happening? You are increasing the volume, but the number of particles that you are not increasing, isn't it? That you are not increasing. So what happens is, everybody, okay, so what happens is you get to see a graph. Okay, you must have seen it in your book also. You must have seen it in your book that there is a graph like this. Yes. And for strong electrolyte, the graph goes like this. It's a straight line. Whereas for a weak electrolyte, everybody, you must have noticed that the graph somehow goes like this. The graph somehow goes like this, isn't it? Yes. That means that the graph never ever cuts the y-axis. Okay. So here what are you taking? Here you will be taking concentration. Okay. All right. And here you take what? Here you take lambda m. So what happens is, for a strong electrolyte, yes, the red one is a strong electrolyte, my dear bachos, okay, this is a strong electrolyte and this is your weak electrolyte. For strong electrolyte, when you continue to, when you continue to extrapolate it, here you get lambda m naught, that is the limiting molar conductivity, isn't it? Here you get the limiting molar conductivity. Am I right, everybody? Yes. Right, everybody? So now what happens, from this graph, there was somebody who was named as Kohlrausch. He came up with a law of independent migration of ions, and he said that the limiting molar conductivity of an electrolyte, it can be represented as the sum of the individual contributors of the anion and cation of the electrolyte. So now here, if it is a weak electrolyte, who can we take as a weak electrolyte? Everyone, will you all agree with me if I say that CH3 COOH, if I take, will that be a weak electrolyte? We all know that it's a weak acid, isn't it? We all know that it is a weak acid, so that means that it is a weak electrolyte. Am I right, everybody? Very good. Very good. See, KCl is going to be a strong electrolyte, but here, if I take a weak electrolyte. Now, let us say that I'm taking this, okay, CH3COOH, what is it going to form? What is it going to form? It is going to form CH3COO minus plus H plus, am I right? Now, at time t, this will be the concentration of CH3COOH, am I right? Yes. But at time 0, concentration of this and this will be 0 and 0, because it has not even started, everybody. It has not even started. Correct, everyone? But now what I can do is, at time t, I'm saying that C and C alpha and C alpha of it has formed. That means that what I can do is, concentration will be C1 minus alpha, everyone. Yes. Right? Right, everybody? So that means that by using this, we can also calculate somehow the degree of dissociation. We can also calculate degree of dissociation, everybody. Now, if we try to read the Kohlrausch's law, I think we will be able to understand what is it. It says that the equivalent conductivity of any electrolyte at infinite dilution, see this, if it goes on and on, it will be infinite dilution, yes, is the sum of the ionic conductances of the cation and the anion by the electrolytes at infinite dilution. Alright, everybody. So if you have an AXBY type of solution, then your lambda naught EQ will be equal to this, where C is the cation, A is the anion, Z plus and Z minus are the charges of the cation and anion. Okay? Ma'am, how you find it so weak? Bacha, hydrochloric acid and acetic acid, if I take, which one will be weak, which one will be strong? Huh? Which one will be strong and which one will be weak? I have just told you that CH3COOH. CH3COOH is a weak electrolyte. That is something that we all know. Why? Why is CH3COOH a weak electrolyte? That's because, see, for example, if I take hydrochloric acid, okay, let's try to understand this. Okay, very basic question you have asked, but I'll still take a little time because we are almost done with it. I'll still try to explain it to you. So if I take hydrochloric acid, I know that if I dissolve it in water, what will I get? I will try H plus, yes. We will take H plus Cl minus, right? Everything will get dissociated. Each and every molecule of HCl will get dissociated into H plus and Cl minus. However, if you take CH3COOH, you will be getting CH3COO minus some amount, you will be getting H plus some amount, and you will be getting CH3COOH. That means this molecule will also be present in the water, okay? This molecule will also be present in the water. That means all the acetic acid molecules, they will not be getting dissociated. So when you are increasing the dilution, do you know what happens? More and more acetic acid, more and more of them, they try to get dissociated. So to certain extent it does increase, but then as you go on and go on and on, and if you keep diluting it, after that what happens is the volume increases but your conductivity does not increase. All right everybody, are we clear with this? Yes. Now we come across the last part of the session, that is your batteries. Batteries you must definitely read from NCERT, but I will still just explain it to you a little bit everybody, so we all know what are batteries. Batteries are basically the plural form of cell. When you take one or two more cells and you connect them all together, that's when it becomes batteries. Batteries, there are two types. There is a primary battery, which once it is over, you have to throw it away. You cannot use it. Like you have dry cell, that is Leclanche cell. Then you have the mercury cell, or you know the ever-ready Duracell batteries. What do? Once you have used it, you throw it, isn't it? You have to throw it off, right? But you also have the secondary battery, like your mobile phone battery, yes, which can be recharged. Yes, what can you do? You can recharge it by passing current through it in the opposite direction. So once what happens is you have some electrical energy that has gotten used. Yes, chemical energy was done, and it has been used. After some time, when you pass electricity through opposite side, it again gets charged. So the nickel cadmium cell, the lead acid battery, like your inverters, they are the ones, these are secondary battery. But still everybody, do not forget to read it from NCERT. And last but not the least, you have also fuel cell. Fuel cells are basically the galvanic cells. What they do is they convert the energy of combustion of fuels. For example, you have hydrogen, you have methane, you have methanol, etc. and they directly convert it into electrical energy. Alright everybody, I think that's it. And one last topic is your corrosion, guys. What is corrosion? Corrosion is when a metal is exposed to some environment, yes, and it gets converted to its oxides. We know that there are different types of corrosion, like rusting of iron, there is tarnishing of silver, there is development of copper patina. Copper becomes, green in color, right? Copper becomes green in color, and that's called as patina. So when it is going through oxidation, what do you see? Let's talk about just the iron, everybody. Yes, so if it is iron, solid iron, it loses 2 electrons and it goes to Fe2+. Reduction also happens here. Oxygen plus 4H plus 4 electron, it becomes water, right? And together it will form an oxide which will be Fe2O3, okay? It will be Fe2O3. Alright everybody, yes, with this note we are done. There are factors, there are how to prevent corrosion, which you know from a very young class, everybody. And there are some more questions that I require you all to solve, everybody. See, look at this, guys. There are so many more questions. The answers are there. This will be a homework. I will be giving you this PDF in the Telegram channel. Where is the Telegram channel? Let me show that to you as well. Here is the Telegram channel. This is where we are taking the class, everybody. Okay. Wait a second. Why can't I see it? Oh, is that so? So the Telegram channel has not been added, no worries, but I think you all can find the Telegram channel if you just go to Telegram and type t.me.vedantu JEE English channel, okay? You will be able to find it, okay? Which cell is the best? You can't say which cell is the best. Fuel cells, they are utilized when you require a lot of energy, right? When you require a lot of energy, that's when you use the fuel cell. Otherwise, normally we use secondary cell. We do use secondary cell a lot, okay? Yes, so it depends on what kind of work you want. So if you want a lot of energy, then yes, you will probably have to go for a fuel cell. If you do not require so much of energy, then I think secondary cell, like in our houses, we use the secondary cell, okay? Alright, so bachos, with this note, thank you so much. You guys are wonderful, and I am gonna take a farewell from you guys. I'll see you soon. Tomorrow, I do not know if I'll be able to take a class. Let's see. Yes, I'm too tired because we have already taken almost more than 3.5 hours. So let's see if I can take the class. If I cannot take it, don't worry about it. I'll be taking it very soon. With this note, tara bye-bye. All the very best. Study well. I will be sending you the PDF. Yes, in the Telegram channel. So quickly go and join the Telegram channel. See you soon, guys. Tara bye-bye. And do not forget to like, share and subscribe with your friends. Bye. Good night.